do pictures and stuff. Correct. I do.
You know that. That's going. They did.
Oh, hold on one second. You just press back. Sorry. Appreciate it. Okay, thank you. Sorry about that, that's all taken.
No, it's okay. It was just like picking up your, on the captioning, it was picking up your whole conversation, but I don't really care.
Oh, because I have these mics on.
Um.
Right, so you got it now? Yep, okay, I'm all good, okay.
Yeah, that's good.
Well, not all, I'm here. But I don't have to like. Did you guys plug all this morning?
No. This has been plugged in for, yeah, there's a lot going on. Probably a little more than needs to be going on,
Yeah.
but it kind of, like, we don't get all the details and then until the morning, so.
Okay, so you actually, you didn't plug all of it.
Some things I plugged in, some things.
Cool.
Yeah. Glad you liked it?
Wait.
Oh, I see, glad you liked
I
it.
think of
Yeah.
why I think that-
No, it is. I agree.
Check that out.
Gotcha. Well, I mean, you can rip it to whatever size you need. Oh, he's got some ones over there, if that helps.
I would look in either. Yeah.
That'll stick better, but white is better. What do you prefer? White. Yeah, David, is to stick things onto things, and that's mostly for writing.
Yeah.
Yep, there is sound. Okay, can we bring up the sound that the graphics machine did? This is an output of, this, that, this is the one, make sure that this, basically, time,
And that you did it for.
Okay, so yesterday I was on the YouTube, so here goes to YouTube live. Yes, I'm looking. Yes, there has, I would like to go back here for the podcast.
You can hear me talk as well. 1, 2 on your phone, hopefully. 1, 2, checking the microphone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check 1, check 2, 3, 4, 5, 6, 7, 8, 9, 10. Check a check. Makes me glad that I'm go.
You guys have gay guys. Put this through.
A little too much.
Make it A and then. You know, I think some of them for you guys. So-
1, 2. Check, check. Check 1, 2.
Be careful. Don't hurt your feet.
Definitely only need the two,
There's some,
because
yeah, just put you out. Yeah, just get, this, that, someone's calling me. Someone's calling me.
Well, I think this is the,
okay, this one's definitely,
There's a cleaner one. Yeah, this is good.
this
Yeah,
one's correct.
this is correct.
I would say.
I'll just do the-
One thing.
oh, no, it's there. No, it's there.
Yeah, this is best, this is good too. Yeah, just put it.
So I would say.
and then- Well, yeah, thing is you have to,
It's really.
the thing is you have to make it.
Oh, is that?
Yeah, just make it.
Yeah, no, this is live because there's,
The thing is.
is there?
Yeah,
I got this one on.
This is theater.
Oh, yeah. I turn the podium mic off. Yes, a check, a check, a check. And you can always step. Yeah. Oh, yeah. But you can also step out of the room too if that helps. Just hear what's going on. Check it, check it, check it, check it, check. Mhm. 1, 2, 3, 4. Check, check, check. Oh, that's coming from them.
This is the Zoom. That's my
Yep.
recording, separate things.
Yep.
So the Zoom is aux2.
Yep.
It's going to this web presenter.
Yep.
Was good, but then it just dropped out. So.
Okay. Yeah. Okay. No. I just dropped it down to see if that was him talking to me, but yeah, it is. I can see it there. Yep. Okay. Hello. Well, that sounds like them talking back to us. Can you hear us okay? I mean, I'm hearing them, but I don't know if they're hearing me. Can you hear us?
Zoom return. We're testing.
Well, I know I'm talking to him right now on
To this. Because
Okay,
there's like a delay going on there.
and now it's too loud. Let's turn it down.
I can hear them, but I'm not.
Say.
1, 2, 2, 2. Well, I'm not understanding what you're saying then, my friend, because.
It's because the live stream, I need to mute their live stream on this computer.
Okay.
All right, so the live stream is now muted on this computer. That doesn't mean it's just, so it won't play back on here.
It's volume. Now it's a little too loud. Oop, it's not a commercial.
Okay. Do you want me to talk? Checking 1, 2.
Want it, 70% about, right?
1, 2. Check 1, 2. 2, 2, 2, 2, 2. 1, 2. Hey, hey, hey. Are you?
Going on that?
Check 1, 2, 3, 4, 5, 6, 7, 8. So you need more or less? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 1, 2. Yeah, there's always a delay. Hello, hello, hello. That's a check 1, 2. Check 1, 2, 2, 2. 1, 2. 1, 2. Hey, hey, hey.
I think 10% less.
Okay.
I can do a little adjustment. Yeah, go ahead, do it there first, and then I can
Okay.
back up.
We'll just take the master down to that's 5. So okay. 1, 2. 1, 2. 1, 2. Check, check, check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How's that? Is it still hot? I mean, nobody's really going to talk on the mic like this.
Perfect.
Awesome.
Yeah, we're not even hitting yellow on here.
Check 1, 2, 2, 2, 2, 2, 2, 2.
If we have to go up, you just let us know.
Yeah, it's perfect because I'm not maxed out and it's pretty loud. Yeah.
All right, great.
That's cool. How did you do that? Just for curiosity's sake.
How did I do?
Turn the volume down for the Zoom.
I just did the feed from to the
Well,
sound
we have
feed to
different
that.
things feeding different things. So Zoom is being fed into this device, which then feeds the Zoom. But because he also logged into YouTube on here, we're getting it twice. So I just muted YouTube on here. It's still like going through YouTube on here. It's going from Zoom into YouTube. But there's one send that all it does is send to this device, which is the audio that.
Okay, so we got audio, and then this is like your between stuff.
Oh, this is just for music. Yep, yep.
Yeah.
This is actually just an extra
Personal.
computer.
Yeah.
It's not personal, but yeah,
Extra.
I'm just gonna
And then
shut
this
that
is
for now.
for audio.
This is it's both. It's audio and video into the Zoom, but the audio is coming through an analog line. The video is coming through a video line. So there are some adjustments I can make on here if we needed to turn it up or down.
Now
Like
do-
the menu, but the easiest way is just on his Zoom.
Can we do a check and have them talk back to us? Oh, okay. So we were hearing the other one.
On Zoom or up there?
No, on Zoom.
I mean, I could be one of those people if you want to check it.
Sure.
That's my job. I'm here to help
Yeah,
with this.
no, great. That sounds
Yeah.
You want to call in or something?
I will.
but that's fine.
Okay, so do you want me to just talk, like log into the Zoom and then talk to you guys?
Sounds good.
That'd be awesome.
I will need the Zoom link.
That's the only thing we really haven't tested yet.
Oh, yes, correct.
Well, we haven't talked to them, you know what I'm saying? We've heard everything the way it should. It should be working. And I think if we just talk to them and they talk to us, we will be secure.
So, can you email it to me?
You would think that would be easy. So
The answer is no. Okay.
it's not that the answer is no. It's just let's do it this way. Because I don't want to.
I got you.
If I log in, it might kick him out.
Sure. We're good. They should have a QR code on Zoom by now, shouldn't they? So I think I want to join, and the meeting ID is 379. Can you read it?
Yep. 379-460-1057.
Okay, we want to turn off the chime when someone enters the Zoom. So that would be in the participants button. Okay, no, then it depends on different people's Zooms, right? So
Right. We can just
yeah, let's go to more. Turn off Zoom chime. So it should be the participants button at the bottom, which we try. Let's try it one more time because it just worked the other day ago. And then in the click the more button. Is there a more button inside of the participants? Well, let's add me while we're there. Admit. And then. Oh, very loud. It's very loud for the Zoom participant.
The recording in progress is always that's controlled by Zoom. So.
this is the word we're looking for. Play sound when someone joins or leaves. We want to uncheck that. What is that sound? Let's see if we can back up. Oh, there. Here, this is a different one. No, it's not. Sorry. But play sound when someone else just has now let's take it down, or I'll leave, and then I'm gonna join again. Because what happens is it does it the whole meeting, and it's very distracting. Okay, cool. Yep, that's fine. We just don't want that ding dong.
All right, checking in the microphone. Check a check a check a check.
It is
One,
very,
two.
very, very loud, just so you know. But I don't know if that matters. People.
Yeah, because I'm at Unity, so it shouldn't be anything weird loudness. It should be just fine.
Sounds correct to me.
Okay.
People can bring whatever that. As long
Okay.
as there's not distorting, I mean,
Yeah.
people can bring their volume.
Yeah, because that's
They can turn their volume up and down.
No, I understand.
Yep.
So right here, this is
One,
like our master.
two, and it's
We're not even hitting
that's
yellow
low,
right
yeah,
now, right?
right.
Never mind. We don't want
So there's no distortion or anything happening at our end.
More like a -6, even
Oh,
-10
really?
now, because they have changed what red is.
12 ideal.
So if it's loud at,
Right, correct. So we're in like the yellow, which yellow is actually -20. We're hitting about -20.
Okay.
It's
I
a
like-
clean signal, like I have original sound on. I can turn it probably.
Check a check 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 check. 1, 2.
well, can't they just turn it down on their end?
They can, but
They
I
can.
will, I will turn this down a little bit because I know our levels are good here.
I'm a musician, so when you
1,
have those
2,
earpods
1, 2.
on and then you blast your ears for no reason.
I turn.
You know what I mean? It's like I don't want to hurt people's hearing on accident if we can.
Yeah, I'm gonna leave the zoom level like kind of in the middle here because I know we're at a good place
Yep, yep.
here. And again,
You're the boss.
you can just let me know if you need to go up or down. We'll do it here. The most important thing is when there's distortion, then everything's good.
Okay, and I'll just check here quickly.
It sounded very clean.
Can I just take a picture of the meeting ID number so I can check later?
I think they can, yeah. I don't know why they're closed right now.
They're closed more so we can control the lighting for the zoom camera, but
Probably you're right.
I mean you can open it up. You know, like it's
We
easier.
usually have the camera facing that way, I don't know why. This room setting is such that people are always facing that way. That's just for talks, not so much for the screen, I guess.
Yeah, they had it requested to do it
This way?
this way. Not even specifically for the screens, but just that's how they requested it.
And what's your name?
My name's Mike.
Hi, Mike. Nice to meet you.
name?
I'm Julie. Julie Heck.
Good to meet you.
Dave. Nice to meet you, Dave.
Have you been talking with Nate? Is that have you heard? No.
Nate from here.
Nate from here? No.
No, I don't know.
If you're here now, and,
Yeah.
I appreciate
Yesterday
your
was
help
at
and
Harvard.
attention to details. It's very helpful.
Thank you.
And
I'm from St. Louis and I work with lighting and sound guys at like the big stuff. But normally I'm just kind of like hanging out. Now I get to be the
Yep.
boss, so it's fun. You know?
Cool.
Yeah.
Yeah,
At
yeah.
Harvard, like okay, upgrade.
yeah, and it's very. I mean, working at BU, it's very different than like the corporate world where a lot of details don't. Things come together last minute more often, and
Oh,
that's just the
in
way it
academia,
is.
you mean.
So I've had to learn to sort of just be okay
Roll
with
the
that.
punches.
You know?
Yeah. Like let go of the control thing.
Yeah, right. Exactly.
Cool. All right, Mike, Dave, I'm gonna go to the restroom. You know where that is? I think it's over there.
Yeah, it's kind of.
Great. Thank you, guys. Hello? Hello? Okay. Sure.
You can do exactly what you're doing. I just wanted to let you know I'm gonna
Okay,
go to this.
cool.
That's okay.
Thank you. Such a lovely view from here. Okay. Sorry, switch the slides? Okay.
So you can just switch on your end, maybe it's
Okay,
easier.
sure.
Yeah, you can just
Cool.
click.
Okay.
Yeah, it's easier for you.
Nice.
So they're not gonna do this.
Oh.
The remote presenter,
He will.
he is going to do this.
Yes. Yes, he will.
He's gonna do slides.
Yeah. Can you just try, let the remote speaker test? Yeah, because we have him right now.
Hello.
Is there only one input or is there two inputs?
There's two, but I thought I had them linked.
Maybe just send another one.
Well, now that I've been back in here, I will, it's definitely something I can figure out. Just distracted by keyboard.
You have time, don't worry about it.
The timer, just sits here.
Need to talk to them? Hello?
Hello,
Turn
you hear
them
me?
up a little bit. Yeah, I'm gonna give you a little more gain here, so I can hear you a little better. Talk to me again. You sound a little muffled.
Okay. Does this sounds better?
That's better. I don't know why it
Okay,
didn't
yes,
sound
I
like that
use
before.
my mic.
Oh, okay. Cool. Yeah, no, you're plenty loud now.
Okay,
Sounding
sounds good. Let me
Sound
try
good to you too?
my yes, I can clear. I can
Nice and
hear
clear?
your cloud. Yes, clear and loud.
Great. Okay.
Let me see what I can share my screen. Yes.
Something just happened there to your sound.
Oh, can you hear me?
Yes, it's cutting out now. It sounds strange. You sounded good before. No. Zoom right here. Yeah. Okay.
Can you hear me now?
You want me to turn the graphics? Hold on one second. We're just trying to figure things out.
Sure.
Okay. For some reason, you sounded great there, and now you're sounding kind of trebly.
Turn original sound on
Okay, let me try it again.
Because it sounded better at first, and now
How
it's
does it sound now?
Oh, yeah. There you go. Now just
Okay.
turn you up a little bit. Talk to me so I can give you a little more gain.
Sure.
Okay.
How does it?
Yep.
Okay.
Okay, talk some more.
Sure. So, can you hear me?
Yep. That sounds great now. Cool.
Let me try my
Yeah, it's much better. It's
MS.
lots more base. Yeah, it sounds much better to us now. Thank you.
Okay, can you see my screen?
We can see your screen and we see you doing your changes.
Let me
Yeah.
swap.
Yeah.
Is it full screen? Play mode?
Full. Yeah. Yeah, it's full-ish. Yeah, that's full screen.
Okay.
Awesome.
One.
Right, right. And, oh, I see. It's full, and we get you in the little corner up there too. Yeah.
Okay, so I move these icons away. Does it look clean to you?
So, could you please not? What was that again? Could you please?
I have you next side by
Sure.
side.
So
Slides.
does the slide look clear on your
Yeah,
side?
no, it looks very clear. Yeah, the slide is very clear.
Yeah,
Okay.
slide looks very clear.
Okay, sounds good. Okay, should be okay. Just brush away. Okay,
Yeah.
Oh, good.
It's all looking good. Yeah.
okay, good. I will stop sharing. So it should be all look good now.
Yep, that's great.
Okay, thanks.
Awesome. Thank you, sir.
Thanks.
5 minutes. Because we're gonna start at Professor Wong will be.
Yeah, do you want to send it? Go ahead.
Okay. If we got
It
time.
would be easier if you joined on another computer, though. Do you want to join the meeting on this computer?
Okay, okay. She's gonna do that.
You'll do it on
Thank
there.
you so much.
Okay, great.
Please make their way back to their seats. Thank you. Great. Welcome everyone and good morning. It's so wonderful to see so many familiar faces from our previous day. But whether you joined us yesterday or are joining us for the first time today, we appreciate your attendance and are excited to be sharing with you the second day of our summit. To introduce myself again, my name is Leah and I'm a student at Harvard College studying economics and environmental science and public policy, and I have the pleasure of being your moderator today. Before we get started, I would like to take a moment to go over a few quick housekeeping rules. We would appreciate it if everyone could keep their devices on silent to minimize disruptions and to please refrain from using flash photography during the event. I would also like to ask you to please take notice of the emergency exits to my right. I would now like to ask you to please take a moment to scan the QR codes above so you can stay connected with us and the exciting work we'll be doing at the Institute in the next few months. To give us a brief overview of today's agenda, our day will be starting off with several keynote speeches, which will be followed by 3 exciting panels on efficient and responsible AI, the next on AI and the grid, and the final one on AI, global sustainable development, all which will be interjected by periodic breaks as well as a formal luncheon. We'll then conclude the event with the closing remarks and a networking event where you'll have the opportunity to connect with each other, the panelists, and us at the Institute. Also, please make note that our staff can be identified by the blue lanyards around our necks and the speakers by the red ribbons on their name badges. Before we begin our remarks, I have the pleasure of introducing the summit's co-hosts, Professor Aisha Kuskon, Professor of Electrical and Computer Engineering and Director of the Center for Information and Systems Engineering at Boston University, as well as Elise Morgan, the Dean ad interim at the College of Engineering at Boston University. I would also like to take a moment to acknowledge our co-sponsors, Boston University's Center for Information and Systems Engineering, as well as the organizers, the Green AI Institute and the Harvard Undergraduate AI and Sustainability Group. I would also like to extend our sincere gratitude to our other sponsors who have made this event possible today. Our Harvard partners, the Harvard Provost Fund, the Office for Sustainability, the Salata Institute, the Center for International Development, the HUA, and the Weatherhead Center, as well as our Harvard Student Group partners, the Climate Leaders Program, the Extension School Sustainability Student Club, and the Graduate School of Education, Coding, and Co-working Club, as well as our external partners, MIT Chief, Asian Americans in Energy, Environment, and Commerce, the Climate Cardinals, as well as the Citizens Climate Lobby at Harvard. And finally, the supporting journal, Environmental Science and Ecotechnology. Without further ado, to officially open the event, I have the pleasure of introducing Jerry Huang, the founder and president of the Green AI Institute. Please join me in welcoming Jerry.
Good morning, ladies and gentlemen. I'm Jerry. I'm the founder and president of Green AI Institute. First of all, I'd love to, on behalf of our organization, to deliver a big appreciation for all the speakers and for all the attendees who come today. Before I get my speech started, I also want to appreciate our amazing support that we have gained from Professor Aisha Kuskon and the Center for Information and System Engineering. And meanwhile, thanks to the Dean as well to support this event for the past few months. So I'm going to give a quick 5-minute keynote and a quick welcome remarks about why we are here today and have a quick recall of what happened yesterday. For us, we are a nonprofit here based on Massachusetts that is in the intersection between these 3 major areas. We're seeing the advancement of AI technologies with bigger and bigger size of the parameters. And there's also a growing demand of the AI energy and environmental impact. Meanwhile, we've also seen that the climate change goal has been pressing more than ever. The past 12 months has been one of the hottest in the human history. So for us, our mission is to build greener and more equitable AI through connecting our industry partners, academia, and also our policymakers for doing more research and push for more policy changes. We started off 2 years ago since COP28, where we are very lucky to meet plenty of like-minded young people. Over the past 2 years, we have been incubated at Harvard Innovation Labs and Harvard Office for Sustainability. And we're very lucky, last year in October, we hosted our first Green AI Summit at Harvard. And over the course of the past 6 months, we have done many things to extend our impact, including launching our white papers and also hosting the summit today. Just a quick recap on what happened last year. As everybody might have known, the AI's energy and environmental impact has been pressing, and last year in February, Senator Ed Markey has drafted the Artificial Intelligence Environmental Impacts Act. To bring more people from industry, academia, and policymaking, we started this from last October, and we're very lucky to have the support of Professor Aisha Koskun and Professor Suchi Gopa, who was very lucky and our honor to join the first Green AI Summit. We carried this effort, and just yesterday, we had our second Green AI Summit, and the first day was at Harvard. We're also joined by Senator Ed Markey and also people from all kinds of industries, including Massachusetts Clean Energy Center, from Meta, Alibaba Cloud, Tencent Cloud, and many other leading academia personnel from Harvard, Boston, and many other places. So today, thanks for coming in this Saturday morning. For us, we're also not just hosting conferences for 2 days. We are carrying out many initiatives to keep the torch going on. We have launched our first white paper last October on the artificial intelligence environmental impact that looks at the 2 layers. From the data center level, what is the scope 1, 2, 3 of its energy and carbon impact? And we compare the policies in the EU, China, and United States when it comes to AI's many aspects, including information disclosure, energy efficiency, waste recycling. And just yesterday, we've launched our second white paper about global data center siting policies and practices. Again, focusing on policies in different states in the United States and also across the world, including Malaysia, Indonesia, and many growing areas for data center infrastructure investment. And we also have an open access journal, which companies from all across the world are sharing their practices of how to achieve digital sustainability. So in the end, I would just want to say a big welcome to everybody who came today, and we love to stay in touch with you by joining us through different initiatives. We use Green AI Index as a way to quantify some of the AI environmental impact, and we also have Green AI chapters, including BU, to host local events. We also have Green AI Summit as our flagship event to invite the leaders from across the world to convene and to discuss. And overall, we're building these Green AI communities for us to share insights and push for tangible impact in the ground. So thank you all for coming today, and we'd love to see a lineup of amazing speakers. Thank you very much.
Thank you, Jerry. I now have the pleasure of introducing our keynote speakers. These speeches will bring together visionary leaders to explore the transformative potential of AI in advancing global sustainability goals. Without further ado, please join me in giving a warm welcome to Elise Morgan, the Ad Interim Dean at the College of Engineering at Boston University.
Thank you. Thank you, everyone. It's great to see you. Really, thank you for the opportunity to Jerry and others in the Institute for the chance to deliver these opening remarks. Also, thank you to the Institute, the Harvard Undergraduate AI and Sustainability Group, and BU Center for Information Systems and Information Systems Engineering, and all the staff, students, and others who put on this 2-day event. It's really impressive. The lineup of speakers and guests really reads like a who's who of leading minds and voices in the space of AI and sustainability. It's my honor to welcome you to Boston University and to welcome you to this building, the Dewan Center, Family Center for Computing and Data Sciences. This building is remarkable for more than, I think, its stunning appearance. It was designed for sustainability right from the get-go and is the largest green building in Boston. It is also tall enough that from the southwest corner of the building, you can see into the iconic Fenway Park. But not to get your hopes up, you can't see quite far enough into it to see any of the actual baseball game. And so in my mind, that means we have the answer to why this building isn't a little bit taller. The Boston University College of Engineering is really delighted to co-host this summit with Harvard, the Students for Sustainability, really because of the urgency of the topic. At BU in the college, we're committed to realizing the immense power of engineering to transform lives at scale. So we know the countless ways that engineering has revolutionized lives by producing breakthrough medical treatments, increasing the speed of transportation and communication, and also creating technologies that might enable a more sustainable world for generations to come. And in BU Engineering, we view these feats of our profession with not just a sense of pride, but also a sense of duty to do even more. So really embedded in our ethos is the conviction that engineering, the purpose is to uplift. It's to create solutions for society, to create solutions for all people to live healthier, more connected, more fulfilling lives, to continue to supply local and global economies with innovation. And when we say opportunities for all, we mean all. Technological progress isn't progress unless it's accessible and enabling to everyone. So with that in mind, it's clear that this summit is right up our alley. Everyone in this room is aware of both the incredible promise and the perils of AI. There's the promise. Many examples, but just one, life-saving drugs could be developed, perhaps in just months. New materials conceptualized and brought into reality. Agentic AI that, among other things, could alleviate us of these repetitive tasks and free our minds and hands for greater pursuits. But we also know the perils, and those include what is effectively the insatiable appetite for energy usage, unless something radical changes. And so, it's time to be radical. What I find truly inspiring about this event is the diversity of expertise that it brings together. This convening enables the convergence of expertise that is needed to chart a path forward. At BU Engineering, we embrace this convergent approach. It goes beyond the idea of interdisciplinary, where experts in different fields work together sometimes and advances come incrementally. Rather, convergence is putting all those people together as a team that does the hard work of learning to communicate across boundaries, learning to learn new things. And when they converge on problems together, they come up with better solutions much more quickly. As we like to say, great minds do not think alike. BU's Center for Information and Systems Engineering is a good example of BU's commitment to convergent research. Engineers and scientists from different disciplines, electrical, computer, mechanical, biomedical, materials and systems, work together with researchers in computer science, computing and data science, earth and environment, mathematics and business to take on challenges in areas as diverse as computational biology, security, cyber-physical systems, robotics, high-performance computing, AI, and more. I'm delighted that the Green AI Institute embraces this convergent approach, bringing together people from academia and industry, engineers, computer scientists, climate scientists, and leaders in public policy and law. It's the surest path forward to a solution that will allow us to realize AI's promise sustainably, to show that we can be responsible stewards of the environment while at the same time advancing the capacity of technology to enable human progress for every individual and every community. That's a tall order, but I'm confident by putting our minds to work and leveraging the collective expertise, we can achieve it. Thank you.
Thank you, Ms. Morgan. I now have the pleasure of introducing Melissa Levinson, the Executive Director at the Office of Energy Transformation for the Massachusetts Executive Office of Energy and Environmental Affairs. Please join me in welcoming Ms. Levinson.
Thank you. Thanks for having me here today. I am Melissa Levinson. I head Office of Energy Transformation here for the Commonwealth of Massachusetts, and I also want to thank BU and Harvard for putting on this event, for hosting, for everybody that's come together. It's a really important topic. AI and the energy used to support it, it's hugely important issue that we're discussing here in Massachusetts. We're discussing it around the country. We're discussing it around the globe, and it's got particular implications, as we just heard, for energy and climate. So I'm really excited, actually, this summit's happening, looking at today's agenda and really focusing on the nexus of energy sustainability and AI in a room full of folks that are committed to really making progress in this issue. It's hugely exciting and it's hugely promising. So with that, I'm going to talk a little bit about how we're viewing it, some of the promise, as we heard about, also some of the challenges that we're seeing. So there's impacts and opportunities in the context of energy, of climate, and AI. So for example, what can it help us do? What do we see as the promise? What are the things that it can really help in terms of climate, combating climate change, mitigating impacts, right? Adaptation, mapping ecosystem changes and its implications for communities and health. This is happening today. Predicting where the next weather event's going to be. We know that we're going to continue to have severe events, but understanding better where they might be, what the impacts might be, that helps us prepare. It can help us save lives. Identifying optimal locations of where to site energy infrastructure, site suitability. This is a huge one. It's something that we're going to be really focused on here in Massachusetts over the next couple of years in particular, as we have to build out massive amounts of energy infrastructure. So where? How can we site it? How can this help us do that? More quickly analyze the impacts of new energy sources on the grid. This takes time right now. If we can cut that time down and figure out the impacts, then we can interconnect more resources more quickly. And importantly, something I'll come back to later, and I know that's a big focus here at BU, it's optimizing energy use, right? How can we actually optimize the energy we're using, enabling some large energy systems, some large energy users to actually become energy producers or to become a grid resource. These are really important things. These are things that can be hugely helpful to kind of reducing the impact, but also providing new technologies, new opportunities, not just in this sector, but more broadly. So these are great opportunities. These are the promise that we see. That said, to deliver these outcomes and these promises takes a lot of energy today. So that's where we are, right? To get to where we're going, to get these outcomes today, we're using a lot of energy. And that has implications for the resource mix that we need and the emissions associated with that, and also for land use. So the concern is that given the rapid growth in data center deployment to support AI, we're going to see and need to see the rapid growth in energy infrastructure build out, in power generation, in grid capacity, and this is challenging. It's not just challenging to do in terms of the magnitude, it's challenging to do in terms of the pace. And I talk a little bit about that issue of scale and pace because that's really where the challenge is coming in. And the reason why this is so interesting and so different for the energy sector is we haven't seen this kind of pace of change really ever in the past 100 years. Even when we look back in time, when we saw the widespread introduction of air conditioning. And I know for many of you, you can't imagine a life without air conditioning. Lots of folks, and some folks in this room, probably lived without air conditioning for a period of time. But when we saw the rapid increase, that was kind of something akin to that, where we brought a technology online that didn't exist really. We scaled it up quickly, and we needed to build infrastructure. But this is outpacing that. And the other issue with that is we're seeing this outpace it in very concentrated areas, and that creates its own challenges. So when I think about, though, what can help mitigate this, one of the big things, and again, we'll talk about this a little bit more, is energy efficiency. Energy efficiency, demand response can really help us mitigate this impact, and that's where AI can also be super helpful. So just to give you some context, one of the reasons why we saw a rapid increase in energy, electricity use around the country, but then it tapered off and it's been really plateaued for the past 20 years, which means we haven't had to build as much infrastructure, which creates its own challenges right now for bringing more resources online, more end-use energy use online quickly. But it's also, over time, helped us avoid a lot of emissions and avoid a lot of cost for customers. So energy efficiency has been hugely beneficial. In fact, in 2024 alone, we saw the economy increase by about, I think it was 2.8% in 2024, but we only saw energy needs grow by 0.5%. So that means from an energy productivity standpoint, right, we gain 2.3%. So that's what I'm talking about of, we can bend that curve, but we can't do it alone. We need to really work hard together at that. So, going to just transition just a little bit to, again, where we need to go and what we're focused on in Massachusetts right now, which is we get the promise of AI, but we also get the fact that we've got challenges that we've got to address. And we're going to need to do that and work on that together. So before diving into a little bit about that, just for contextually for Massachusetts, for those not as familiar, what we're trying to do here and why this kind of convergence of AI with achieving our climate goals is actually creating a lot of pressure on the energy system today. So Massachusetts, we have nation-leading climate laws, so achieving zero net greenhouse gas emissions by 2050, and we've got an electrification-based pathway to get there. So that means we are relying on electrification of buildings, of transportation, right, widespread across the economy. We're also relying a lot on energy productivity increases to get there. And we're also really wanting to make sure that as we do this, we're doing it in a way that we're growing opportunities, right? We're keeping environmental justice in mind. We're making sure that we're providing benefits to all communities, and we know that that's something that's been challenged in the past, and that's something we're incredibly committed to in the Healey-Driscoll administration. And as we do this, we also need to keep affordability front and center. So that's a lot of things we're trying to balance as we move forward and as we go to achieve our climate goals. We've made a lot of progress on these goals, but we're now hitting a point of around how do we execute? How do we balance the opportunities with the challenges in making progress? And that's why we created the Office of Energy Transformation here in Massachusetts. It's actually the first in the nation. And really what it's focused on is bringing together the energy ecosystem that we have here in Massachusetts to address some of the complex interrelated issues. And I'll talk a little bit about what some of the focus areas are, and you can kind of start to see some of the nexus with AI and what we're talking about here today. But what we're really trying to focus on is how do we move past kind of the fossil-based economy that we have today to a cleaner energy economy? What does that mean? What are the complexities? How do we move from a system where we're reliant on multiple fuel sources to one where we're going to be primarily reliant on electricity? How do we do that at pace and scale? What are the technologies? What are the innovations? Right? What do we need to do about that? And that's what the focus of this office is really about. So a couple things just to kind of dive in on, and you can start to see some of the relationships. One of the things that we're focused on in this office is how do we transition away from a very expensive piece of fossil fuel infrastructure we have right over here in Boston Harbor that is reliant on global supplies of liquefied natural gas, which are fluctuate in price based on global markets. So again, it's an expensive asset, inconsistent with our energy needs, but critically important to meeting them right now. So how do we move away from that at pace and scale? At the same time, how do we move away from some of our most inefficient power generation facilities we have? These are facilities that they fire up when everybody else fires up everything that they're doing all at the same time. They're incredibly useful. They dispatch energy quickly. They're also our least efficient, most expensive, and they rely on fossil fuels. So if you think about a world of AI computing, everybody's doing things all at once. You're doing it at the same time that people in their homes and businesses are firing up. All of a sudden, we can drive up peak demand. That drives up emissions and drives up costs. So we need to think through, how do we do this? How do we pay for all this? We're already seeing a lot of affordability challenges. We are very committed at the Healey-Driscoll administration to making this transition equitably and affordably. As we add more demand and need more resources on a system, this can become challenging. So again, we need to make sure that we're doing everything we can to drive affordability, and that means reducing the amount of infrastructure we need to build and the amount of energy supplies we need to buy. And finally, one of our focus areas is how do we do all this sustainably? How do we continue to grow the economy, expand the economy, right? Build out our life sciences, our research, right? Our innovation, be able to export all of that around the world, around the globe, but do it in a way where we are maintaining, right, our progress on climate and clean energy. And that's, again, what all of you are here to talk about in the room, but that's what we are focused on at OET, which is why I was really excited to come talk and understand that this convening is happening. So just what does this mean? So what does this transformation mean? putting it in context, we are moving from a system that's been heavily reliant on fossil fuels, natural gas. It's been there, it's been a resource, it's been a very solid resource for us all. But we need to meet our climate goals, we need to move away from that, and we also need to move away from volatile fossil fuels that we import into the region, that we don't have control over. We want to move towards a system that is more local, right, that is more stable, and that has less influence by volatility of what we're seeing around the world. So this is where we're going to. We're moving from a system that you can see is heavily reliant on gas to one where we're projected to be heavily reliant on renewables. And that's great. That also has implications for how the system operates. So we're going to need to consider all of that as we grow and expand our needs. So we're doing this, and again, we're evolving not just the energy that we're using, but we're evolving how we use it and when we use it. So this is projections of what we're seeing for demand growth over time. Like I said, these are the kinds of increases that we haven't experienced in this time frame, I think, at least in the past 100 years in this industry. So we're expecting a doubling of demand. This was before that we saw what we're expecting to see now for data center growth and AI here in New England. So this is before that. So a doubling of peak demand before that. Again, and then being reliant on assets, on resources that are more intermittent in nature, less dispatchable. So we need to figure out solutions together of how we can continue on our path of developing and deploying clean energy resources while meeting our 24/7, 365 energy needs that we know growing industries and growing economies need. So that's where we are. That's kind of the pieces that are coming together, changing both the energy supply mix, changing our energy demand needs, all at the same time. So that means when we think about it, we're going to have to build out the energy infrastructure to support all that. While meeting just the electrification needs of transportation of buildings is challenging, meeting the electrification needs of transportation buildings and what we're seeing as the needs of data centers all at the same time is exponentially challenging. And why is that? There's a difference. So I'm going to use this as an example. If you sort of think about a world where we're going to, say, build 50 new buildings, so equal to maybe one large data center, typically it would be kind of not something you would typically see, kind of 50 large buildings, all electric, go up in a concentrated area all at once, say in an 18-month period. That typically is not going to happen, right? So we could see that, we could plan for that. They're not all going to be built at the same pace and time. They're not all going to be occupied at the same time. So you can plan an energy system, while challenging, to meet the needs of, say, 50 large electric buildings all coming on at once. A data center, however, it can be built in 18 months. And it would have the same energy needs as 50 large buildings in a concentrated area. So now think about that energy system. How do I meet that need? How do I meet that need while also meeting the needs of the community around it? That's the challenge we're facing. That's the conundrum. That's where everyone in this room can put their heads together, put their solutions together, right? How can we work through these kinds of challenges? So it's not just the scale, it's the pace. And when you put pace and scale together, that's what really becomes the really interesting part of energy transformation, and that becomes the part where we all have to work together. So what are some of the things we can do? What are some of the solutions that are emerging? And these are, again, conversations that are happening all over the country, not just here in Massachusetts. Some of the solutions that are emerging from data centers are, first, co-locating or bringing their own energy, recognizing that what I just talked about, the fact that you're really increasing energy demand in a concentrated area very quickly. Can you bring your own energy resources? Can you co-locate maybe at a facility that right now maybe has excess capacity? So these are things that we're seeing. It's an emerging trend around the country. Secondly, new technologies. New technologies that are actually making computing more efficient. So, right, how can we leverage semiconducting technology to actually increase the efficiency, right, reduce the energy needs, dissipate kind of the heat, right, heating and cooling needs. These are the issues, right? The cooling is what drives a lot of it. So if you can do that and transfer that energy, right, at lower temperature, you actually can, and save that, right, less dissipation, you actually can be much more efficient in your computing. So how can we leverage technologies in other areas in this industry? And then finally, and I know a lot of work is going on here at BU around this, around how can we use AI to actually figure out optimal load management, demand response. How can you actually, right, use the computing technology to actually not just develop the solutions, but actually do your computing at times maybe when we don't have a peak demand issue, right? You can do the computing at times when we have excess energy on the system. Can you leverage that not just as, right, figuring out a solution, but as a grid resource, as a demand management resource? These are the kinds of things where we're all gonna have to work together to figure out how can we make it more efficient? How can we actually leverage the technology as the solution? And how can we leverage the technology to help bring more clean energy supplies online so that we can manage affordability, we can manage reliability, we can meet our needs, and we can meet our climate goals. It's a tall order, it's a big task, but I know it's one that everyone in this room can work on together, that we can figure this out. We're excited here in Massachusetts to do it. We're excited to work with you all, and we're excited to do what we always do in Massachusetts, which is to innovate, right, to show others what can happen, and then to export that, not just around the country, but around the globe. So thank you again. Really appreciate the opportunity and appreciate everything everyone here is doing.
Thank you, Ms. Levinson. I now have the pleasure of inviting to the stage Professor A.B. Brown, President Emeritus and Professor of Engineering and Computing and Data Science here at Boston University. Please join me in welcoming Professor Brown.
It's really a pleasure to be with you this morning on a perfectly dreary day with a wonderful view of what Boston can look like in the fog. I decided, talking with the program coordinators, to talk a bit about something a little different off of your topic of AI and the green economy. I want to offer some perspectives on the opportunities and challenges for AI research in research universities like Boston University and Harvard, and the challenges for the students and faculty who are at the vanguard of this revolution. Two forces are colliding in research universities today across the country. They are the rapidly advancing frontiers of AI in research and application that is an important underpinning of the agenda of this meeting. And at the same time is what I'll call the assault that is underway against research universities by the federal government. There is devastating damage being inflicted on these institutions, not because we are either inefficient at the research that we have conducted over the last 75 years, or that our wonderful graduates, many of whom are in the room, have not fueled our knowledge-based economy, but because we don't all agree politically on the present administration's views. I mentioned that research universities are 75 years old, indicating a birthday. That date is May 10th, 1950, when the National Science Foundation was created by act of Congress, and with it the peer review system for proposals that has become the bedrock of the American university research system. A system built on peer review to fund the very best ideas in support of the universities in their dual missions of research and education. And when I say education, I mean both undergraduate and doctoral education. I've been studying research universities, and even before the Trump administration, I have worried in writing about their sustainability. I have worried out loud whether the system would make it to its 100th birthday, which would be 2050. Now, some mornings I wake up worrying about whether to make it to the 75th in 2 weeks. New England is the home of the largest concentration of major research universities in the country. And the pain of these cuts will be felt across our campuses. Nothing that I can say this morning will reduce this. However, there is a way that we can create a ray of hope in this system. The path is through collaboration
and the explosion of AI research and all of its implications and applications should be the incentive for us to do this. I am not an AI expert. I am a recovering university president. It's a long recovery, I found out. Who in my research career used applied math and numerical methods to study fluid mechanics and materials. I am in tune with the need of computational resources for researchers, whether they be data centers for AI or classical supercomputers. Early in my career, these resources were only available to a few. Algorithms were developed by individuals and research groups, and performing state-of-the-art calculations on available computers was an art passed from one generation of these researchers to another. I've spent much of my career first collaborating across disciplinary boundaries and then attempting to build organizations that bring together institutional strengths. Recently, I've been assisting the Commonwealth of Massachusetts and our research universities in establishing a major AI collaboration, which I'll describe in a few minutes. But first, I want to give you two examples of the history of research of computation in New England to set the stage for the new AI initiative. It was in the early 1980s. Now, many of you can imagine how long ago that was. And large-scale numerical simulation was beginning to play a role in engineering and science, but individual research universities had a hard time joining the revolution because of lack of access to computers. The first supercomputer I used when I was on the MIT faculty was at Los Alamos through what was then called an ARPANET account. And as a result of that, I have a 3-letter password, which is now becoming very rare. Now, at that time, in the mid-70s, the state-of-the-art, see if I can make this work, was a Cray 1 supercomputer in 1976. How many have seen a picture of these before? Not very many, right? This was the state-of-the-art in 1976, and I have on that slide some of the specs of the machine. I think the most important thing for you to think about is the weight. We used to call it big iron in my time. You might want to call it a big abacus, right? It's actually, if you look at the specs and the computational power, it's more like a very expensive iPhone, right? MIT and Harvard tried to form a consortium to win an NSF supercomputer award in the early 1980s. We asked the state to help. They declined, saying that our research universities were strong enough that we should be able to do this by ourselves. MIT and Harvard joined a consortium in New Jersey with Princeton and Rutgers and started a center there. Now let me fast forward to 2010, almost 20 years ago, some time you can think about, when again there was an attempt of universities to collaborate on computing infrastructure. This time it was not about buying big iron, a shared computer, but about building a shared data center. And that time the state supported the idea, and the Massachusetts Green High Performance Computing Center, MGHPCC, was born. Established in Holyoke, Massachusetts, using a new hydroelectric power that was available on the Connecticut River. It was one of the first really, truly green data centers run by a university in this country. The members of the MGHPCC today are BU, Harvard, MIT, Northeastern, UMass, and Yale. It's not only a Massachusetts endeavor now, who are all have the majority of their computing resources in Holyoke. Each institution viewed the center as what I will call a pre-competitive collaboration, allowing us to do more efficiently, use resources together than we would separately, i.e. one big data center. Last fall, members of the state, members worked with the state to take this collaboration to another level. With the leadership of the Healy Driscoll administration and the support of Yvonne Ho, Secretary of Economic Development, and Jason Snyder, Secretary of the Executive Office of Technology Services and Security, the state launched an AI initiative aimed at building the human and physical infrastructure so that AI flourishes in Massachusetts. This is a long way from the passive approach of the government to economic development in the 1980s, and very welcomed. The MGH-PCC is at the front of this, front and center of the initiative. As we will host the AI computing resources for the initiative, it will be funded by the members of the MGH-PCC and the state to give a compute infrastructure that is green for the universities, partners, and startup companies. We expect to install the first phase of this machine in early fall, and then phase the machine in over 3 tranches to the point where it is one of the largest university-accessible AI machines in the country. I can't tell you what it is yet because we're right now in the middle of bids for whose machine it's going to be, but you could take bets. With the establishment of the AI computing resource, the collaboration between these universities has moved to another level. It moved from sharing a building and an electric bill, that's how we jokingly always talked about what we did before, to share computing and human resources for working with our community for the development of foundational AI and its applications. This is an incredibly positive step for the universities in Massachusetts. But it still does not take us deeply into the land of collaboration. This is my challenge to you this morning, is to, as you explore the frontiers of AI research and green computing, let's go together. Let me make the case. This sounds simple because true collaboration this sounds simple. However, true collaboration is not a trait that is traditionally expressed in research universities. Our institutions have thrived since 1950 on competition. Competition for graduate students, for faculty, and for grants. The result has been a vast system of research universities. Boston alone has 5 members of the American Association of Universities, the AAU, the 71 premier research universities in the country. And we have 4 other Carnegie R1 institutions, very research intensive, for a total of 9 out of 174 in the country. We are a research mecca. The question is, how do we maintain this position in a world of diminishing resources? Collaboration can play an important role, just like coming together to share computing resources. There is much to be gained by collaboration on research projects, where our collective strengths make us overwhelmingly competitive, and where the research communities we form will give us scale and variety that would be difficult to have individually. Just as this AI forum is organized jointly by Harvard and Boston University, imagine more frequent group meetings driven by shared projects and collaboration and funding. Wouldn't we be stronger and more vibrant? And there is the next level of infrastructure that will define much of our impact with AI, and that's data. Data for training algorithms in areas of emphasis. This could be life science or healthcare or government databases for climate and energy. Just as we collaboratively support hardware infrastructure, the universities could benefit from collaborating on the acquisition and curation of large-scale databases. How does research collaboration happen? University leaders can say they applaud it and provide some incentives, but in the end, it is you that makes it happen. You decide that the whole is greater than the sum of the parts. You decide to work together. This summit is a critical step in that direction, but I hope it is not the last. Data science and AI are an enormous knowledge revolution in our society and in higher education. We need to seize this opportunity to evolve our organizations, both inside and out, to lead in this new world. I want to close just by giving a plug for the building. Elise already talked about it as a green building, but I also think of it as a building that is connecting people. It houses those faculty units that are at the center of the AI collaboration. One, called the Faculty of Computing and Data Sciences, is composed of faculty, both in CDS, as we call it, but with joint appointments across the university. This cartoon shows a span of CDS as of last fall. The span will be greater at the end of this year because of the hiring season. The world of research universities is changing rapidly. In fact, it's going to change more rapidly than we've seen in 75 years. We must deepen our collaborations, leveraging our collective strengths so that these universities make it to their 100th birthday. Most of you will be here when to see if we do. Thank you for listening, and have a wonderful day.
Thank you, Professor Brown. I now have the pleasure of inviting Professor Yonggang Wang to speak. He's a professor and president's chair at the College of Computing and Data Science, as well as the dean of the Graduate College and associate provost of graduate education at the president's office at Nanyang Technological University in Singapore. Professor Yonggang Wang will be joining us online. Please join me in welcoming him.
Thanks a lot for inviting me. Can you hear me from the audience? Okay, thanks. It's a great honor to share some of my perspective from the Southeast Asia in Singapore. So actually, this talk was motivated by a observation which during COVID, because of human activity was reduced to the bare minimum, and there was expectation that the global carbon emission will be reduced significantly. But after the COVID, IEA did the analysis that in early 2010, due to the human activity reduction, the global carbon emission only reduced by 5%, which is probably pretty much margin of error. And then actually people trying to find the explanation why there's no such a big reduction in carbon emission. One possible hypothesis was because of the online activity increases that actually increase a lot of carbon emission from the digital infrastructure, as we have been talking about this today. So then I was further look into this potential hypothesis, and then came across this one idea from the European, talk about the twin transition between digital and sustainability. On the one hand side, we move more and more of our digital our activity to online, and which make our life easier, and in some cases is necessity during COVID. At the same time, we also facing this challenge of sustainability issues. So as a researcher in computer science, what we are trying to look at is one possible way to address this twin problem, trying to find the sweet spot where we use AI and data science try to reinforce the sustainability. So that's the idea we're trying to develop. So based on that hypothesis, I will share three aspects. First, I will look at the AI-derived sustainability challenge, as the keynote speakers earlier mentioned. And also, AI have the power to actually transform the AI sustainability space by helping other industries. And finally, I'll conclude my talk with some final thoughts on the twinning AI and the sustainability. Let me start with the AI-derived sustainability challenges. So as we all know, one of the key requirement for AI is we need huge data centers. And this digital transformation actually have a tremendous impact on the sustainability. One way to look at how much energy this data center will consume. In 2020, there was a paper in Nature, estimate by 2030, global data center will consume close to 8% of all the electricity. And in Singapore, we conduct a study in 2017 to find out that by 2030, being a small nation on the map, but our data center will grow tremendously and will consume close to 12% of all the electricity in the world. And as a result, probably some of you guys heard about in 2019, Singapore have this moratorium on new data center built until last year, which was lifted. So over the last 2 years, one of the main topic is the large language model. But as we all know now that this large language model actually makes the systemic challenge even more severe than before. So here I just using these three major large language which was announced quite early. Look at the Llama and GPT-3 and Palm from Google. How much energy it would consume to train that model initially? So as you can see, the amount of energy consumed to train this model actually increases as the parameter size increases. So this is actually quite understandable because one way to measure the data center energy efficiency is the power usage effectiveness, which defines the ratio between the total energy consumption versus IT equipment energy consumption. As you can see, globally, this number actually plateaued at the 1.5 run, so there's no one had a good advantage. But if we translate this amount of energy into the specific carbon emission, you can see different companies have different numbers. Actually, they are not growing linearly as the parameter size. Actually, that pertains to another parameter in data centers, CUE, carbon usage effectiveness, is the total carbon emission versus the IT power consumption. As you can see, Google clearly stand out in terms of green computing technology. And so actually, it's well known that Google has really good data center technology, especially in green data center technology versus other companies. So that's understandable. So if we further look at the other large language models, as you can see, the parameter size increases, in general, the energy consumption to train that model actually increases. If you look at log scale, then you can see that this actually grow exponentially. So it's not sustainable. So therefore, one needs to look at these problems. So specifically, let's look at the future energy trend for generative AI and or large language models. So we know that the large language have two stages: training and the inferences. So let's look at what are possible energy trend in the future. If you look at x-axis as the AI adoption, y-axis as the energy consumption. Let's look at the training. So it's my belief that in the future, there'll be only limited number of large language model or foundation model will be trained. So I assume that energy used to train these models will roughly stay constant. But if you look at the inferences, as we can look at some of the examples. So the one way to measure is the energy consumption per token for inference purpose. Roughly for the mainstream models is 3 to 4 joules per token. So therefore, the more we use, actually, the more energy. The more we use this large model, the more energy it will consume. As a result, so if we stack these two together, so we'll see that in future, the data consumed by the generative AI will grow tremendously as the adoption increases. Not only that, as the time evolves, the dynamics between training and the inferences also evolves over the time. Now in 2024, there's 85% will be training, and while in 2028, by estimation, the inference will take majority of this energy consumption. So that actually changes the way our researchers can do in this domain. So therefore, we want to optimize the computing energy efficiency to actually make that line actually a straight line. In computer science, we call that energy proportional computing. So actually, if you look at the whole data, AI data, DC4 AI, then look at different layers. We often adopt decompose that into different layers, try to address these issues as a result. So we can look at this problem one layer to each other, and also possibly look at the cross-layer optimization, try to improve the energy efficiency for AI DCs. So one of the specific ideas we've been working on is this software-defined green computing architecture, try to learn from what we have done for networking, software-defined networking, to actually use advanced processing capability in the control and the management plane to actually to look at the CPU and GPU usage to try to minimize the energy consumption for a certain amount of computing we need to do. So some other ideas include, we can also leverage the different carbon intensity across geolocations, try to do the task scheduling across different geolocations, such that the total carbon emission from a certain task can be minimized by leverage the low carbon intensity in countries like Finland, Norway. They claim that carbon negative data centers. While places in Singapore, we have no choice because we don't have natural renewable energies to power the data center. So these are also the ideas we've been looking at. And not only that, we also can look at different energy mix, try to optimize that way to green in the compute in AIDC. So actually, we worked on a economics model, some economics model, try to estimate the cost of using different energy sources to power data center. Look at the capex, opex, as well as decarbonization cost. Then, if you put this together, it's clearly one can see that the renewable energy is the obvious choice. But for places like in Singapore, we have limited landscape. We don't have this renewable, so then we have to look for other potential solutions. And so one possible solution we are looking at in Singapore is we are using the hydrogen powered data center. Actually, one proposal has been discussing, probably Professor Brown heard about from MOE. And Singapore is actually we are trying to build in a hydrogen power plants in one of the islands. Actually, 6 gigawatt hydrogen power plants trying to power the data center in the main island. So the good thing about the hydrogen power is that it's really reliable. But of course, at this stage, the cost is too high. So actually, you will expect that 2040, this cost, the price between the hydrogen power and the liquid natural gas power will be become even. But for the time being, government decide to use tax or the credit, try to bring this price close to each other to entice more people using hydrogen power for data center. So the other idea in Singapore we've been talking about is to actually we're trying to leverage the solar power in this outer space as well as the cool the cool temperature in outer space to cool down this data centers. So actually, one idea is to launch the data center in the outer space. So we potentially could have some good benefit. Actually, we did the feasibility study show that as long as the lifespan of the satellite or server is around 6 to 7 years, the life cycle carbon usage effectiveness of this spatial data center is about the same as the terrestrial data center. So actually, as some of you already read in the news, in the China, Europe, and the US, they are both public sector as well as private look into the possibility of launching data center into space. Actually, 2 weeks ago, there was an article in Economics talk about this issue as well. So if you're interested, I suggest you read that article. And so the final ultimate solution is using nuclear powered data center, nuclear to power data center. And actually, there's a lot of research talking about this as well. As this big company like Google, Oracle, and Microsoft all start to look into using signing the potential contract to use nuclear power to power the data center. So that just talk about the AI derived data sustainability, but at the same time, AI is a very powerful tool for us to address some sustainability challenges in other sectors. So actually, one idea I've been thinking about is look at how data can help us. So actually, I basically classify this AI into business AI and physical AI or industrial AI. Business AI is using AI to transform how the cyberspace, and we all know there's a lot of companies working on that. And the other aspect is to use AI for physical spaces. Examples being factory, field, fleet, and facility. These are the energy-intensive industry, which also have a huge room for us to optimize to improve the energy efficiency and reduce carbon emission as well. So actually, just use the data center as an example. Came out of Cisco. I like the way of eating your dog food using AI to address the data center challenges as well. So actually, one of the research we are doing is actually we are developing this physics informed machine learning approach for us to look at the data center energy consumption and optimize the operations such that we can improve the energy efficiency and reduce the carbon emission as well. So actually, this research has been licensed to an NTU spin-off, Red Dot Analytics, for commercialization purpose. It has been receiving few awards in Southeast Asia. So just using a specific example, actually, this is one data center in Singapore, 1.1 megawatt data center. We use a digital twin and AI to do the design and the operations. In the design stage, we can reduce the carbon emission by 3,000 times. In the operation stage, we can reduce the PUE from 1.5 to 1.4, and resulting close to like 2,000 tons of carbon reduction on an annual basis. And so actually, this technology has been also deployed to a few commercial data center operators, including Iron Mountain, Equinix, and BDX. In our initial trial, the result was quite positive. The saving can be from 5 to 30%, depending on the actual operations. So actually, if we take this technology to extrapolate into a larger scale deployment in Singapore context, if all the 1 gigawatt data center capacity all use this technology, we estimate that it potentially can save the close to 400,000 tons of carbon emission. If we extrapolate this into a global context, potentially it could have gigaton level decarbonization for data center industry, which will be on par with the carbon footprint of Japan or the combination of Canada and France in 2022. So these are the other side of story. We can use AI to help the data, to help the industry. So now it's a good time to actually put these two together. So if I put these two together, again, use the same diagram to show how the dynamics between these two sides. So if I assume that I can do best energy efficiency for green AI, so I can achieve this energy proportional approach. At the same time, the more AI use, we hope to actually save more energy in other industries. So then at a certain point, we can see the AI has a new technology in our society actually does more good than the bad to us. So we believe there was some sort of inflection point. At one point, AI will do good better. So actually, then in order to prepare ourselves to do AI for other industries, actually, there are a few things we need to put into places. And as a professor in computer science, people often ask me, what should we do for AI? So actually, I come up with simple idea for people to prepare the AI project. So just assume AI as a moonshot project. So you will need a few things. First, you will need a platform, like this engine in this rocket. In our AI is CPU or GPU, particularly GPU platforms. Also, you will need good AI researchers as the pilot. And then you will need algorithms as the roadmap to guide where you are going. And data as the fuel of the rocket. And often, the last one, but often overlooked, is the application. So where we are going. So in Singapore, anything more than 3, we cannot memorize. Actually, I just take the first letter of these 5 keywords. So come up this simple message for people to memorize the AI waste product. So you need 5 ingredients to prepare for a good AI project. Of course, it also begs the question: why should I do AI? How does AI help my economy grows? So actually, then there was a study last year to show that the computing power index versus GDP and for 15 top economy in the world, then they found out that if the computing power index increased by 1 point, the GDP growth will be 1.8 thousandths, as well as digital economy growth by 3.5 thousandths. And so this number is not intuitive. Then I asked my students to look into some economics model, try to understand what the real impact. Then found out $1 investment into AI and digital infrastructure actually result in $15 gain in digital economy output and $29 in GDP output. And for this AI and digital industry to versus other industry, actually semicon, energy, renewable energy, ocean economy, as well as healthcare. So it's clear that it's obvious to us that AI and digital infrastructure actually is a good is a good sector for government or private sector to invest on. So then this is a good message for all the researchers working in this space. Actually, what we are doing actually can help the economy grow tremendously. So with that, I'd like to conclude my talk with the final thought is to prepare for AI, there's two sides of the story, as well as one can use the AI as product, and also AI will help the economy grows. Thank you.
Thank you, Jerry. Thank you, Alex. 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 Thank you, Jerry. Thank you,
Thank you, Professor Wang, and to the rest of our wonderful speakers. If I could please invite all our speakers to please make their way back to the stage so our photographer can capture a group photograph.
Let's welcome the speakers for the entire day to join us. We can do a group photo for all of us here. Yes, I think all the speakers can join on the stage. Oh, okay. Yeah, but yeah, all the speakers from all the sessions will join us for the photo. Yeah. Okay. Yeah, I can go. First one. Hi, Priya. Yeah, please. I need a bigger stage. Yeah. I think. Well, I'm just.
Yeah. Well, they'll figure it out, I think. Yeah.
No, present card, please.
Go, you.
I can't. You should. You spoke already, we didn't yet. I'm not liking anybody, right?
Are you okay? Yeah.
It would be a fun picture. Thank you so much. So Jerry, you may want to announce people to come back quickly.
Yeah.
Like
Sure.
just a.
Yeah, just 2 minutes.
Because of time constraints, we're going to have to cut our break short, but we're going to take a quick 1 to 2 minute break right now before we start our first panel. Thank you.
Is the intention for her?
Nice to meet you.
No worries.
Sure. Nice to meet you.
But I gotta tell you, the panelists here have a good view. Right? Yeah, no, it's better than being in the audience. Yeah. For the first time ever.
It's good?
I live in Kansas.
Okay. Not plus 5, but plus 5.
Just
50 minutes. Okay. Don't look too angry, okay?
If you want. That's okay. That's okay.
very dynamic.
Apologies everyone for the shortened break, but to stick with our timing today, I would like to introduce the first panel of the day. This panel will be on efficient and responsible AI, technology solutions for a greener future. The session will highlight advancements in machine learning systems that prioritize energy efficiency, reduce storage requirements, and overall sustainability. It is my pleasure to introduce the moderator, Yasemin Kazani, the Vice President of Data Science and Machine Learning at Ru-Gilt Group. Please join me in welcoming her, and she will introduce our lovely panelists. Thank you.
Thank you very much. It's a pleasure to be here. Although gloomy, I still love this view, and I would always say yes to any invite that brings me to this room. It's an honor to be here. I'm the least expert in anything we will be talking today, so it's all on them to bring all about green AI and the efficiency and responsible AI to your attention. So as was mentioned, the panel title today is Efficient and Responsible AI and Technology Solutions for a Greener Future, hopefully. Our goal today is to dive into how we can reduce the environmental impact of AI, not just in how we build AI, but also how we use it, and how governance and innovation can work together to get us there. I am going to be asking each one of you in your first question to give a little intro, because I think you guys would do a much better justice introducing yourself. But while introducing yourselves, starting from here, can you also, each one of you, share a quick sentence on how you define green AI as a whole? So Priya, I'm going to start with you.
All right. Hi, everyone. So my name is Priya Donti. I'm an assistant professor at MIT working on physics-informed machine learning for the operation of high renewables power grids, and also one of the co-founders and chairs of Climate Change AI, which is a global nonprofit that aims to foster the impactful use of AI for climate action. And so what I would say as my definition of green AI is AI where we are kind of efficient about the inputs that we put into it, so how kind of consumptive it is, where we use it for good things that actually support climate and sustainability goals, and where we avoid using it for bad things that are actively counterproductive to climate.
Thank you.
I'm Jay Jackson. Thank you for having me. I work on AI infrastructure at Oracle. For those who don't know what we're doing well, we've been building some of the largest supercomputers in the world for OpenAI, xAI, NVIDIA, ByteDance. And with that presented some interesting challenges for green AI. How we have defined it is actually similar to how Professor Wen defined strategic planning for AI, as inserting green AI into every one of these processes, from the core infrastructure and design to the platforms to the applications.
Thank you, Jay. Paulo.
Hey, good morning, everybody. I'm Paulo Carvão. I currently a senior fellow at Harvard Center for Business and Government. But I had a 30-year career at IBM in which, amongst other things, I've led the systems hardware division for the company, in which we were in the business of providing the infrastructure for clients building their data centers. And I was thinking about green AI and the definition. I actually changed the definition this morning, listening to the rest of the presentations. And I would say that green AI is the only possible AI. And the reason why I'm saying that green AI is the only possible AI, let's think about what we learned this morning, right? The NFL, Foxborough Stadium would consume 10 megawatts of energy, right? The Stargate project would consume up to 15 gigawatts of energy. This is like, you can do the math, right? It's whatever. It's like thousands of times more. So the equation will not close. So either we find a solution for the green AI problem, or we do not have a future for AI.
Thank you, Paul. Steve.
Wow. My name is Stefan Ginger from Vienna in Austria. And for more than 20 years, I was serving in the banking and finance industry on the side of the regulator and also on the side of banks and insurance companies there. And in Europe, we are quite blessed with regulation. So we are quite experienced in different kinds of regulations. So I now serve as a regulatory consultants for different clients there. And when I think about the term green AI, when I first read it, I thought it's a contradiction. What do these two terms have in common together? But coming here, I understand it's some kind of a vision. Yeah? And in philosophy, as soon as the word is out in the world, you invite the world to change accordingly. And this is one thing that I really like at this conference. Thank you.
Thank you. Kate?
Hi, my name is Kate Sayenka. I'm a professor of computer science at Boston University, and I'm currently at Meta at the FAIR lab, the Fundamental AI Research Lab, doing research in computer vision and multimodal models, large language models that understand images and video. And I've been doing research in AI for 22 years. And the last few years, people started talking about green AI. And I think that's a sign that it's, entered the collective consciousness of the world in a way that it didn't before. And we're realizing that both challenges and opportunities. I think green AI to me means machine learning methods that can reduce the overall carbon footprint, energy consumption of the human race, both by not adding to it and by reducing it and improving challenges in climate change and power and energy grids, like actively, designing machine learning methods to improve these things.
Thank you. And we have Shreyank joining us online. So you want to go, Shreyank?
Yeah. Am I audible?
Yes, you are.
Hi, I'm Shreyank Gowda. I'm an assistant professor at the University of Nottingham in UK. I predominantly work in computer vision like Kate. I've been working in data efficient learning and memory efficient learning right from my PhD, internships, postdoc, and so on, in like different types of modalities, so images, videos, and medical imaging. And a big motivation for my research was with the lack of resources that we had compared to companies and universities. It started with that sort of motivation, and then over time, coming from a country where I've seen the lack of water, like there's so many situations where people don't even have access to drinking water, and meanwhile, one conversation with ChatGPT is taking half a liter of water. So these kind of things strongly motivated me towards like green AI, and I think green AI itself as a topic is really large. And I would just say my part in it is to like look at ways that we can maximize models' performance while ensuring that they're computationally efficient, use less resources, and basically, yeah, they use less resources and less memory. And that's the part of green AI that I work in.
Thank you, Shreyank. Really appreciate it. So we're going to dive in more into what green AI really means and the direct impact it has to applications, the systemic shifts. So Priya, maybe get us a little deeper into your view of green AI. And I also want to ask, do you see any hidden impacts of AI showing up that public or companies might miss it? So what are the hidden layers?
Absolutely, thanks for that. So I'm actually going to start with a base. I really like sort of Kate's kind of framing of green AI, right? We want AI to, in some sense, be an asset and kind of a net positive in kind of decarbonization and climate across society. And in the public narrative right now, how that's often framed is AI can be an asset for climate action because it can help us better optimize power grids, it can better kind of help us discover next generation technologies, it can provide insight to policymakers. But also AI can potentially be a hindrance because of its direct carbon footprint and its energy footprint, water, materials, and so forth. And the story stops there. And both of those things are indeed very important. We do want to make sure that we're leveraging AI where it's helpful for climate action. We do want to be bringing down the direct impacts of AI. But that's not the whole story. We also need to be cognizant of the fact that AI is a general purpose technology that's used across many different societal applications, including some that are directly counterproductive to climate, like accelerating oil and gas exploration and extraction, or kind of accelerating, let's say, like methane-intensive bovine agriculture and kind of entrenching those existing systems. AI is also inducing various systemic shifts in how we consume goods and services, how we consume information, and also in terms of who holds the kind of power in society, in the sense of who is selling solutions, who is driving directions as we increasingly digitalize things and AIize things. And those undoubtedly have implications for climate that are not often factored in. And then there's kind of another pot of applications, which is places where AI is being used for applications that, depending on the direction they go in, could either have kind of positive or negative implications for climate action. So things like the use of AI for autonomous vehicles could serve the purpose of entrenching kind of privatized energy-intensive transportation, or it could serve the purpose of helping us reduce the emissions from the transportation sector and the energy from the transportation sector by allowing it to become easier to use multimodal and public sources of transportation. And we're actively making choices in these applications that actually have implications for climate action. So I think a lot of these dimensions are often missed. And I think that a reductive narrative can lead to kind of perverse action and perverse incentives, because if we stop the narrative at AI can be used for good things and we have to mitigate the direct impacts, then the actions that are taken are, okay, let's slap some AI for good applications on top of our business as usual, let's green the grid, and let's just pretend that the rest of the stuff doesn't exist. And instead, I think kind of aligning the use of AI with climate goals, with green goals, means really thinking about how we kind of steer the ship of the entirety of societal AI use towards a pathway that's compatible with those goals.
That's very interesting. So basically, a lot of how we are bringing AI right now is that we sort of add a layer of AI on top of how we do things. And what you're saying is we need to shift the whole thing to sort of capture it as a whole. Is there anything like, from like your experiences that you see like you've been doing that, or vice versa? Like, which one of these two patterns you've seen, and if either of them have worked better?
Well, it's just continue to explore this theme of the kind of the hidden patterns, right? So I would just volunteer a framework for people to think about it. As we commonly talk about the AI triad of algorithms, compute power, and data, right? And looking at it across the supply chain is a good way to kind of surface those. But I would suggest there is another triad that is emerging, more focused, Priya, to your point, on the social technical aspects of this, which is around energy, land, and labor, right? Energy is basically a lot of what we've been talking about here. Land, we need land to build these massive data centers. And labor is, what are the labor implications, right? Not only the typical labor dislocations that come with AI, but even for this construction boom, right? What impact this will have in local communities. We have peaks and valleys in terms of labor, et cetera. So I think looking at through this, the physical supply chain, the technical supply chain, but also the social technical supply chain with this new triad, that's could be helpful to surface some of these.
Maybe one thing that in this assessment, especially this bi-directional perspective, good for climate, bad for climate, that you have pointed out quite brilliantly there, that fascinates me sometimes is the side stages next to AI. I mean, we are here now at the stage of AI, green AI, and we have some other stages where things are happening. Yeah? And especially when I have a look at, for example, India, with the largest biometrically database that was ever created on Earth, the Aadhaar system. And we have their biometrical data covering also demographically data. We have the 10 fingerprints, we have iris scans, we have a measurement of the face morphology. And this, now highly regulated by law, puts us technology-wise in a position to one-to-one identify a real-world person and his or her actions in the digital sphere there. Yeah? And when you connect this with AI, for example, not allowed now because of regulation for sure, very severe and strict regulation there, when you connect that, let's see what's happening there with a more amount of data. Yeah? I mean, we have our smart watches that help us to become fit, and remind us of our exercises. Maybe we can also measure all those data points when we perfectly identify the individuals and give some real-time carbon footprint on the smartwatch, for example, helping the individuals to act accordingly. Yeah? This would be the bright side of that. I think we're all creative enough to also imagine some dark sides of this data transparency.
That is amazing. So I want to move to the the development of this technology. So, like, you know, we have researchers here on the panel, Shreyang, Kate, have extensively worked on building AI. Shreyang, I know that you've been exploring innovations, as you mentioned, on efficient AI, given, you know, lack of resources, or just basically what we want to push forward with, like, you know, edge development, edge deployment of AI. So how can these approaches help lower AI's carbon footprint? So similar to what Stefan was suggesting, what are the things that we can actually do to bring down that carbon footprint? And are there trade-offs between these model performances and the energy efficiency of what you're building?
Yeah, thank you for the question. So I think even Professor Wen spoke about this. So a lot of the carbon footprint of AI is not just from training these large models, but then you also have to deploy them, and then you're running them inference repeatedly at scale. And I work on, I can broadly now put like 3 directions of work that I do on, which is like parameter efficient learning, edge deployment, and data efficient learning. So all these 3, I think, can help quite a bit in terms of reducing carbon footprint. So parameter efficient learning, for example, things like adapters, quantization. So these things help us to like fine tune and use these like really large models without the need to like retrain them or run the entire model. So basically, instead of updating billions of parameters, we're like adding a small fraction. So with this, we can reduce compute, memory, and energy demands like by quite good margin. Then edge deployment, for example, we can like run models closer to where the data is generated, like on mobile devices, sensors, or like local servers. So then instead of relying on energy intensive centralized data centers, we're reducing the need for constant communication with remote servers. So we're cutting energy use and latency. And basically with data efficient learning, the reason that I do quite a bit of research in this is there's this general trend that you use more and more, larger and larger data sets to like train your models to make them better. And this is not necessarily true. And if we need to find efficient ways to train this by using less amount of data. And basically all these approaches together, they make efficient AI not just like training or inference, but along its full life cycle. So we're not talking about just green during development, but we're also talking about deployment and then everyday use as well.
Thank you. And so while we are hearing the research and basically like doing these things at the university level, I'd like to turn it to you, Jay. Like, you know, how does that sort of turn into when you are deploying these things as a company and you still want to make sure that...
Yeah, I couldn't agree more with Shreyang shared. We learned the hard way that there are very few engineers and even people who can speak to the entire stack of AI efficiency, right? Like I'm pretty deep in the hardware and the infrastructure, but then we have to pull experts from the data layer and then experts from the algorithm layer and then all the pieces in between like compilers. And so without having a couple people that can speak to this entire ecosystem, like you lose all these potential gains along the way. And so for us, like when we're deploying AI into our large application suite, for example, we want to deploy the most cost efficient and clean green AI, but without having thought through this entire stack, you kind of miss the plot. You may get one part right, like you may have quantized your model or you may have deployed a smaller model, which is great, but you may miss on 3 other places you could have improved performance in inferencing or with the core infrastructure. And so that's been a learning exercise for Oracle for the past 3 or 4 years is without bringing this entire domain together, you're missing out on the potential upsides in different places.
I think that's a shared experience in any level of AI that you bring into production. Like, you know, from my personal experience, like when you have sort of historical pipelines of, let's say, like just data processing, you know, you have some ETLs and you want to bring a single model and you've basically promised that, oh, this model is optimizing one task by 90%, by 150%. You bring it and then all of a sudden your pipeline runtime sort of explodes, right? And you have to go back. And as you said, like, it doesn't even have to be like very new technology. Whatever change to your stack that you're making, that end-to-end optimization and knowledge is really the key. So like,
and there's easy stuff like resource planning. Like we spend a lot of time with Meta and others where you have data all over the world, and Professor Wen showed this too. Like there's a cost to move data from Singapore to the US. There's a cost of having a bunch of different storage locations. So like resource planning is like a seemingly easy thing to do, but really hard at scale.
Yeah, and then you want to add like, compliance of like, you don't have to have any downtime. So like, you have to. Awesome. So like turning this into you, Kate, I want to understand so all of these like optimizing it at local levels for like, each of AI developments that's going on is a hard task as we hear. Does open source help us with that? Open sourcing AI help us with that, or is there a challenge? Is it more like a challenge on sustainability, or is it more of like an addition?
Yeah, I think open source is very important to this whole discussion. And by the way, by open source, what I mean is not just publishing the model weights, but also the data recipes, the training code, all of the parameters that went into the training, how many times the model was trained, and the energy efficiency even of the hardware that it was trained on and it runs on. And there's very little incentive right now for companies to publish these details, and a lot of the research I see on actually trying to estimate the energy cost and carbon footprint of AI models struggles to even make those estimates because you don't have any data. It's like, it's sort of like trying to estimate the carbon footprint of an airplane where you don't have access to the airplane. You can't go inside. You can't look at the engine specs. You don't know how many passengers it fits or how far it flies. Like what can you do? So I think that's number one, is just kind of a push that we all can make. I don't know, maybe as academics, consumers, or advocates to encourage companies and that develop these very large models to actually release details about them. And also, I think we're in a bit of a crisis right now in terms of reproducible machine learning research as well. Like it's very difficult to come up with new techniques and algorithms when you can't directly compare to state-of-the-art models because they're opaque. You don't have access to them. You can, only use them via APIs. So, it's nice to develop these efficient approaches, but if they're not adopted broadly, they're not really that useful. So, yeah, I think it's an opportunity, really, and I think we should push more for more openness in this whole endeavor.
So my question here for you is, there could be an argument in AI technologies that historically it's been okay for things to be secretive, right? Like, even your, body wash details is not open, right? Like, we don't know what's in every shampoo that companies build, right? So what are really the incentives? And this is like for everyone. Like, how can we incentivize what we are asking in terms of this openness and sharing? I understand the need, I agree, but I want to know, yes, as consumer, I can make the push. As consumer, maybe I can pick something that's open source. But what is that extra leverage? How can we bring it, from policy point of view, from consumer point of view?
Just real quick, one very quick thing. Everyone from now on, if you want to generate a meme of Studio Ghibli, use Gemini and not ChatGPT because of the plot we saw earlier. They're more carbon efficient. Go ahead.
I think, and maybe I'll jump a little bit into kind of the policy side of things also, but before going that, I want to go back to this like epiphany that I had in the morning that the equation is not going to close, right? So I think there is an underlying economic incentive for trying to do something different, right? As companies like Oracle, which is part of the Stargate project, or Meta, or my former company, etc. If we wanted to continue driving progress with AI, something's got to change, right? Because this thing is not going in the right direction, right? So I think fundamentally we need to be thinking about the incentives in the system. So there is this underlying economic incentive to try and drive towards shared innovation so that collectively we can attack the problem. And then I think that's where policy can have a role directing those incentives. And if there's any area in which policy has played a role to foment as opposed to stifle innovation is environmental.
Yes.
So if you think about, from the 70s, right, when we started the discussion about when the EPA was created and all the progress that we have made in internal combustion engines for cars, this was driven by policy. And since we have a large engineering audience here, engineers design and drive to constraints. So if you put a constraint in front of an engineer will find a way to do something different and create and innovate. And so regulation could be a way to create these constraints, to drive that innovation, and through effective policy, guide innovation in a safe and responsible and sustainable direction, right? So I think that's the way I would maybe connect the two dots here.
And just maybe building briefly on those last two comments, like, yeah, we often frame this in terms of incentives, but there's some things that are incentives and some things that are requirements. And looping back to this example of the shampoo bottle, sure, I as the consumer am not looking at that ingredient label super carefully, but I have some trust that somebody at a regulatory level who had the expertise to evaluate it looked at that and said, there's nothing in there that's going to kill you as far as we know. And so I think that kind of at some level, right, there has to be some entity that is able to do this and where they actually have the parameters and information to be able to do that properly, and where we're not trusting sort of self-auditing, right? Exactly. Like there has to be sort of the ability for an external entity to the solutions developer to have enough information to do this auditing.
So I think we are going basically to my next set of questions very organically, which was around policy and governance. So this was mainly for Paul and Stephen, from what you have been, looking at what you've been involved, what kind of laws or governance models you think will help make AI development more energy aware and climate positive? And I think we've already gotten into maybe more specifically, I want to understand if there are anything that we should learn from EU's Green Deal regulation that the US or other countries should be adopting.
Yeah, adding up on what Paolo said, I think this is a major function of policy and lawmakers to create these constraints, be it technically, be it economically, and trust that the market and the companies will find solutions. You mentioned the Green Deal. We've heard yesterday from the lady from the Commission about the Green Deal that was passed in the first term of office of Ursula von der Leyen's Commission. Now, we are seeing at the beginning of the second term a significant, how it's discussed, cutback in the Green Deal, especially in those regulations regarding transparency and carbon border administration there. So I think what is to be learned from that, what I have seen in Europe when it came to those directives, to those laws that normally have very long acronyms, like CSRD, Corporate Sustainability Reporting Directive, or CSDDD, Corporate Sustainability Due Diligence Directive, CBAM and EU Taxonomy, for example. These directives, there is now the first proposal of the Commission here to cut those significantly back, those reporting obligations. But I think in the second step, where they are now modifying the Green Deal, they are seeing that some of the requirements were a little bit overshot for the industry. In the reporting, major companies had to calculate and fill in thousands of data points there, creating a huge cost amount there. And the industry was also complaining in the first round of the Green Deal, especially in those directives that are now modified, that that they were not heard in there. And the Commission had the drive to do something good, to save the environment, to become the first CO2 neutral continent. But now, at the beginning of the second term, they are now significantly modifying. And I think for the regulator, this is some lessons learned. When you want to make AI, when you want to make the world a greener place, when you are going to do something good, it still might be quite helpful to also involve the others, those who have executed that. Listen to the representatives of the industry, like you do it with many other laws there.
And just to simulate a little bit that dynamic governance model that we discussed yesterday, and for those of you that were not here yesterday, but it's a model that I have proposed that have basically 3 steps: standards, compliance, and then liability and accountability. You can define as a policy goal, not necessarily a horizontal policy goal that are like, for example, govern frontier models, which is like too broad of a goal, but a goal could be very germane to what we're doing here, right? So goal could be data center efficiency, how we're going to do this. So together with the industry, we can define standards, then we can have solutions to, and a market-driven process for compliance to that, and then we can have enforcement mechanisms that will kind of create liabilities in case you're not complying to the standards that you have set, right? And then iterate this as you as you learn more, right? So these are ways to kind of creating a more dynamic set of policies that could not only drive innovation in this needed direction, but also create the incentives, be it through fomenting something or to creating liabilities that would help enforce it.
So one question I want to add here is what Stefan mentioned was bringing representatives from industry, maybe from academia. How can we create that? Maybe like, from both, from an industry point of view or from like a policy point of view. How can we push for that within the policymaking, lawmaking here within US?
So what I have seen, some of it from my previous life, but a lot of it through the recent work that I have done, researching this with the industry and with policymakers, is first, the industry has an interest in some policy and standardization in this area because there is an emerging fragmentation of legislation, which is very difficult to comply. And also, we're in the middle of, unfortunately, an example of lack of stability in the policy area, being not good for business with what's going on with many different areas, including tariffs. And so stabilizing this environment so that it can have long-term investments. And so I think there is an interest in the industry and, eventually, even for, liability protection, because as we drive more and more AI into business processes in the economy at large, things will happen, right? And so you'd better be prepared to and protected on how you're going to not expose yourself to an undue amount of liabilities.
I agree, and industry can move really fast, right? We had to adjust very quickly to new tariffs. We had to adjust really quickly to the AI diffusion policies, and so when there's change, we can react. But without stability, it's difficult. Without pulling the right people together, frankly, like there's not that many groups building these frontier models. There's not that many people supporting infrastructure at this level of scale that's driving 15 gigawatts of power. So pulling the groups together is actually not that hard. There's a dozen groups, and so I think like that's my encouragement for everybody is if this is a space you're interested in, like force your way into that room and like pull these people together because we can react really quickly. Like the incentives we put around green AI or better ways to access power, like there are opportunities there if we get the right people collaborating.
And maybe like turn it from a react to a more proactive industry-involved policymaking. So we're not always on the reaction mode and more. That's amazing. Thank you. Well, I think both of the directions that we discussed were more like, on the EU side or, on the maybe less stable policymaking theme here. How can we promote international collaboration? And I think we touched up on it a little, but like when things change and there is, growing tensions, like where would we be able to push for the right incentives to create more internationally compliant AI policies.
I don't want to speak too much, but I think there are two things, and you just mentioned AI diffusion, right? Yeah. So AI diffusion is a term that became more and more apparent after the Biden administration has announced the AI diffusion framework, actually 2 days before inauguration, and it's one of 2 executive orders from the Biden administration that have not been revoked, which signals that there is something that will continue. So if you think about this battle for leadership, there's a battle for technical leadership. Who's going to have the best frontier model, which nation will dominate, etc., which is important, interesting. We need to innovate, including from a sustainability perspective. But I think there is a second battle that is even more important, which is this battle for diffusion. Because whoever gets the technology adopted by the world at large is the one that will win this battle or war. And from that perspective, there's an element of AI diplomacy. And diplomacy only happens through collaboration and sharing, right? So we cannot make every engagement into a confrontational negotiation, right? And so I think this is another way to think about how international collaboration will have to happen. On one hand is to solve this problem, which is a problem for humanity, right, that we're discussing here. But the other one is even if you're interested in being a leader globally, you need to diffuse your technology and you'll have to collaborate to make that happen.
That's amazing. So turning it a little back to how AI has been positive and negative for climate action. One thing I like to understand a little maybe more, Priya, and for everyone is how can we use AI to actively accelerate climate actions, and maybe go a little deeper on which areas you've seen a faster adaptation, energy forecasting, carbon removal, agriculture. Where is it that's giving you hope that here we're going more positive or faster into a positive impact?
Yeah, so I think there are a lot of places that AI has been used for climate action. So things like leveraging data like satellite imagery and turning that into kind of actionable insights that decision makers can use. So for instance, there's a coalition called Climate Trace, which is using satellite imagery and on-the-ground information to get kind of entity-level granular estimates of where greenhouse gas emissions are being produced that can be used as kind of third-party transparent input to the international climate negotiations. AI has been used to kind of forecast kind of solar power production and electricity demand in order to help us balance power grids more effectively. For instance, there's a nonprofit called Open Climate Fix in the UK that worked with the UK power grid operator to actually have the error of their previous demand and supply forecasts by basically using more advanced machine learning models, as well as by actually being more clever about the data they were using, kind of combining things like historical weather data, as well as things like satellite imagery or videos of clouds moving overhead in order to get more granular estimates of solar power production. AI is being used to optimize heating and cooling systems in buildings in order to kind of improve their efficiency by taking into account kind of information about weather, occupancy patterns, so forth. It's being used to approximate time-intensive simulations like climate models in order to allow us to get more fine-grained information about kind of how the climate will be affected. So things like if I'm trying to plan power grid infrastructure in the future, kind of what is the effect of kind of climate-related changes on my literal infrastructure, on my wind power production. So we can kind of approximate simulations to do that. And then there have been a number of uses of AI in sort of scientific discovery and clean technology development to try to do things like if I'm trying to create my better battery for power or transportation use, how can I learn from the outcomes of past experiments in order to kind of suggest which experiments to try next, and as a result cut down the total number of experiment cycles that are necessary to create that better battery. And I think one thing I'd like to emphasize is that kind of across these different use cases, so right, like touching many different sectors, many different ways of using AI, it's really important that kind of the way this is done is in close collaboration between those with technology knowledge and problem owners, and that we recognize that there isn't kind of one type of AI or sort of one homogenous kind of approach to developing AI that kind of trickles down benefits to all of these applications. These applications all have different requirements. That means we have to innovate on AI differently in each of these settings. And also, because there are so many settings, it's important that we have some amount of ground up development of these applications where we're really also empowering problem owners to develop and shape these technologies rather than just assuming it's sort of a one-way kind of diffusion from technology developers to problem owners.
So the accessibility of AI becomes very important because, like, you want to make sure the problem owners who may not be complete, like, technologists can actually, that's amazing, yeah. My lightning round question for the end of it was, what gives you hope? And you gave me a lot of things that, okay, these are the good things that we can hope. I'll start with Shreyang in the final, maybe like take 2 minutes each of you and tell us, maybe complete the sentence. One thing that gives me hope about the future of green AI is.
Okay, so bit broad, but so I would say from an application standpoint, I think I would like to add to what Priya was mentioning. So I see one really good use case in agriculture, for example. So countries where there has been lack of water and how do you use your resources more efficiently? And I think that's something that AI has clicked pretty well. There are a lot of startups in India, for example, that are coming up with like smart farming techniques, what crops to grow, where can you grow them, how much water to use, like seasonality and things like that. And for people who aren't really that educated, I think that's something that's helped them a lot. So that gives me hope. And I'm not talking like from my research perspective, I'm just talking about green AI in general. So I think that is something that I'm really optimistic about even for the future, that this is something that can help a lot of people.
That's amazing. Yeah. Thanks, Shreyang. Kate, I'm going to start from that side. Maybe tell us what gives you hope about green AI.
So, I mean, I think AI, what I think of it, how I think of AI is just technology and software. Everything, we used to say software, and now we just say AI. Yeah. I mean, it's everywhere. It's just the new software. And what gives me hope is I think we've seen many times that technology is good at making things more efficient. I mean, think about like how often you used to have to take an airplane to go meet someone, and now you can meet them on Zoom. That's good. That's more efficient in terms of energy. So yeah, I think it's just going to continue to make everything more efficient, including climate, energy use, carbon footprint. So yeah, that's my hope.
Thank you.
Yeah, adding up on the efficiency that Kate mentioned, I think it gives me hope that yesterday I have learned that the AI was very good at giving prognosis about the breaking out of fires in California there. So when the AI as a powerful tool can really help us to make ourselves in our actions more powerful, this is something that really gives me hope. And maybe it's just data. I did not understand so far. Yesterday we have learned 95% of the data is private, and all the AIs can only use 5%. Maybe we are going to change this proportion a little bit.
I think about innovation. Innovation gives me hope, and maybe inspired by this view, I was reflecting about the history of AI. I don't know if you guys know, the term AI was created 70 years ago when a group of scientists from MIT, from Harvard, from IBM, it was 6 of them, decided that they wanted to spend the summer of 1956, so they wrote a proposal in 1955 for trying to spend a summer in Dartmouth and in a few weeks resolve all the issues related to this emerging field. They were a little optimistic that they would fix this in a few weeks. Here, 70 years later, here we are. But if we reflect about what we have heard in the last couple of days, advancements in microelectronics, electronics, algorithm design, efficiency. This is nothing short of magic in the eyes of those 6 scientists that were writing that proposal 70 years ago. So if we imagine a world driven by innovation 70 years from now, I can only be optimistic.
That's amazing. I heard that story in one of my interviews at IBM as a proof that IBM never ceases to create problems for you to solve. So if you join as a scientist, you always have a problem to solve. I remember one of the interviewers told me that story. So I guess that's it. Like, you know, they created problems that will have to have enough in new technology to build for.
Or maybe observe problems in the world.
I think we share a similar worldview here. I was also going to say innovation, but I think actually incentives are one of the things that I have optimism for, because there's so much opportunity and then so much downward pressure on things like cost that we are forced to do some crazy innovation in these data centers. And so we're forced to solve the green AI problem. We're forced to solve reliability challenges. And so like some of the incentives are lining up in a way that I don't think 12 months or 18 months ago they were lining up, where we have to solve these problems if we want to build at this scale, or it's impossible. Like you teed us up that we're going to build ridiculous scale in the next 18 months. I don't think any of the charts we've showed today actually reflect the right inflection point of where this power is going to go. And so the incentives are lining up well. So that's what I'm optimistic for.
Thank you. And you want to share more?
Sure, yeah. I think one of the things that gives me hope is just the number of kind of incredibly smart and motivated people who are like working on these problems and really thinking about them thoughtfully and all angles, right? Like lots of people innovating on how we can use AI for climate action, lots of people innovating on how to bring the energy use down, a lot of people thinking about the kind of regulatory and broader kind of holistic aspects. And I think as long as we continue to have this really kind of awesome ecosystem of people who are both kind of thinking about, you know, how we can kind of take advantage of the incentives that do exist and how we can kind of change our systems in cases where the incentives don't align with our overall goals, I think we're going to do great.
Yeah, and the key would be for those people to collaborate more, right, per Professor Brown's comments. Awesome. I think I'm finishing right by time, right? And really thank you for a great panel. I learned a lot listening to all of you, and I hope you enjoyed it.
If I can capture a group photograph, that would be amazing. Thank you. We will now proceed with a 10-minute break. Please be back here for our second panel to start at 11:25. Thank you.
such a misconception of the like including by the regulators because they've been told like these are 24/7, 365. And so anyway, I'm so glad you weren't already. I just wanted to like sort of I guess they're going to do their demo on the board.
Yeah, you're getting bombarded with questions like Hannah. Nice to meet you. I had a question about kind of this, knowing about the full scope question, because so I'm at Harvard, I'm a grad student, but I'm trying to help organize this course for a potential master's developing like energy tracking and sustainability tech. And so I was just wondering, what do you feel that means for education of the different disciplines that come together in AI? Is it, should they know really well their specialization and then on the job kind of?
pick any order you want. So we can sit like this. And let's just leave the last few chairs empty. Should we start? Maybe I'll give another minute for people to walk in.
I would now like to introduce our second panel of the day. This panel will be an AI and the grid, complex interactions. This panel will be an exploration of the interplay between AI, renewable energy grids, and data centers. Please join me in welcoming our moderator, Professor Ayşe Koskan, who's the Electrical and Computer Engineering Professor at the Systems Department at Boston University. Please join me in welcoming Professor Koskan, who will be introducing our panelists. Thank you.
Thank you all for joining. We have a very distinguished panel of speakers in this AI and grid interactions panel. So our goal here today at this panel is going to explore this intersection. What can AI do for optimizing the grid? In various ways, from optimizing the grid operations, intelligence, all the way to flexibility and demand response. So we want to explore some good practices, challenges, and potential future threats in this area. So the first part is introductions. I'd like every panelist to briefly introduce themselves, and then we'll go ahead with questions.
Yeah, hi, I'm Hendrik Hamann. I'm a recent professor at Stony Brook University. I'm also an AI chief scientist at Brookhaven National Lab, and before I was chief science officer at IBM Research for 25 years. I do believe the reason why I'm here is because I had the chance to create a large community of organizations, roughly 100 organizations from industry, utilities, technology, academia, which focuses on building foundation models for the electric grid, so non-text-based foundation models. And I'm excited to be here. Thank you.
Thanks.
Hi, everyone. Good morning. Thanks for coming out. I'm Tyler Norris. I'm a fellow and a PhD student at Duke University focused on bulk electric power systems research. I've had sort of a career in energy before this. I did electricity market forecasting at S&P Global. Developed large-scale solar and storage power plants for a few years. Also worked at the Department of Energy, but I've done a lot of work in regulatory proceedings in front of public utility commissions and FERC to try to get better outcomes on resource planning and interconnection. I think the main reason I'm here is because we recently did a paper looking at the opportunity for large load flexibility to mitigate the need to build out a lot of new fossil fuel infrastructure. And I think we kind of got the timing lucky on it. It's gotten a lot of attention. It's called Rethinking Load Growth. I testified to Congress based on it about 6 weeks ago, and we're really excited to try to figure out how we can integrate these loads in a more flexible way. So thank you.
Thanks, Tyler. Ellie?
Good morning, everyone. My name is Ellie. I work for Eversource Energy, which is your beloved utility. I guess everybody knows us now that our rates are up. Joking. I am a graduate of Boston University. I did my PhD in the Systems Engineering Department. Worked with a lot of professors that I see here, many familiar faces. Graduated in 2017. And so my role at Eversource, as you'll see, is a manager of system reliability and resiliency planning. What does that mean? Eversource, like I said, is the utility. Eversource is transitioning to being a data company. So my team is one of the main data and modeling teams across the company, trying to provide kind of data and actionable insights at the fingertips of other teams to deploy and implement them. So looking forward to the discussion today. Thank you all.
And Junwei?
Hello, everyone. My name is Junwei Cao. I'm from Tsinghua University, Beijing, China. I'm actually with information science and technology in Tsinghua University. But in recent maybe 15 years, I mainly work with the state grid of China and the China Southern grid doing research projects like we are using AI optimization to build advanced applications for the power grid systems. So I'm very looking forward to today's discussion. Thank you.
Thank you all. So the first question I want to ask is, what can AI do for the grid? So what are some interesting projects? What are the main challenges we are facing to implement or apply artificial intelligence related to solving grid problems? And we can start from here.
Yeah, I think the widest use of AI for the electric grid has been in the forecasting domain, so load forecasting, generation forecasting. There have been countless successes, I would say, where either AI complements traditional load forecasting techniques or other forecasting techniques, and so that is certainly an area. I think where AI has been struggling is in two ways. I would say most of the AI which we have still in the electric grid is somewhat bespoke. And why is that a problem? Well, it's a problem because it prevents scaling, and scaling means better economics and also probably more robust models, et cetera, et cetera. So we still have a scalability issue. And then the other one is really finding the use cases in the electric grid for AI which provides sufficient value. You would really, so there would be enough incentives to actually implement that.
Yeah, so there are a lot of applications, and one of my concerns actually is that we get a little bit distracted by these kind of fun bells and whistles and sort of miss the forest for the trees, because AI, if it's going to be green, it has to help us with planning the system in a way that can integrate lower carbon resources and to operate the system such that it can do so. And I think there's a lot of misconception, right? So for example, take the grid interconnection process. A lot of this isn't AI, it's just process automation essentially. And most of the models are deterministic. So I think there is a question, like how can it be applied? And I think one opportunity is, for example, when they run these power flow and sort of stability studies, oftentimes the humans don't think of sort of more innovative or creative arrangements that could mitigate the need for network upgrades. And so I think if an AI agent can sort of look at the problem and suggest alternatives, that's one opportunity. And then in the operational realm, to the extent that AI can help to foresee or to respond to disturbance events based on training on other related or synthetic events, that could be valuable. But I think let's not get distracted by just sort of the fun and interesting use cases. Like, we have a serious crisis in front of us right now, which is that we are barreling towards tens and tens of gigawatts of additional gas build out in response to scaling hyperscale data centers. And also we're extending the lifetime of coal plants right now. This is happening as we speak. And so if we can't mobilize to figure out how to mitigate that, it won't really matter like all these fun use cases we can find. Like, we have to avoid massive fossil fuel expansion and lifetime extension if we're going to have any possibility of making the AI green.
Thank you. Thank you. Ellie?
It's about data, that's correct. It's about data that's clean, that's available, that's consistent. The utilities, why are we in this conversation? We're in this conversation because we own and operate the transmission and distribution grid. So we are the means to push that clean power. We are the means to interconnect those large loads. That could be the data centers. And so the data is not clean, the data is not available. Utilities, like Hendrik said, have bespoke systems where this data sits, and this data was not formed, these software systems and the way the data is gathered were not even formed for bulk kind of batch processing, so much for taking them and putting them into a learning model. Manual inputs, free-form fields, the works. And they're also bespoke because each utility does their own thing, and it's really difficult to scale and make a solution move from utility to utility and grow fast. I'll tell you a little example to start on why data is so important, even within the same company. We have software systems that we use to operate in a silo. Like 4 or 5 of them are relative to what I do. And so we created a chatbot. It's one of the contacts in Teams. You can IM it, and it cross-references these 4 software platforms and gives you an answer. So we try to do that, ask a question about one of the towns that we serve. Eversource serves Connecticut, Massachusetts, and New Hampshire. And we didn't realize the question we asked, that town, that name exists both in Connecticut and Massachusetts. And so our bot just responded with some averages, some sums, some maximums of the towns that have that name. And we didn't know that. And so what we found out is that we actually, because of the way we formerly used to operate, kind of locationally and decentralized decision-making, we have so many fields that don't have unique identifiers. So that was kind of an important step for taking this data and actually doing things with them in terms of learning models and AI.
Thanks, very interesting. Junwei?
Yes, I can also give a detailed example that over the last decade, we are working with power grid company in China, especially in southern China grid. We are working with the Shenzhen power supply company. You know, Shenzhen is the southeast city in China and very near to Hong Kong. There are many high-tech companies there. But the problem is there are a lot of power quality issues for the customers. They sue the power company that like there is a voltage sag and then my production line stopped. That caused lost. So that's the problem. We worked for over 10 years with the Shenzhen power supply company to identify the reasons for that. For example, there is a thunders, and especially in South China, it's quite frequently happen, especially in summer. And there will be voltage sag transferred from the grid side to the customer side. There are also other reasons that maybe there are some load in the customer side that caused the voltage sag that transfer to the grid side. So that's issue. We have to collect multiple channels of data from the power quality monitor devices, also the operation and the scheduling data, even the customer size data. We collect them all together and to do the correlation between data and to trace and diagnose the problem and to help the power company to make work procedures to deal with this situation. That's an example that I think the AI and algorithm and maybe broadly speaking, a data-driven method could be used in the power grid company.
Thanks a lot. I'd like to dig a little deeper in this data challenge. For AI, AI needs data to be successful. So what are some regulatory challenges? What are some technical challenges around this data? Is it merely an availability issue? Is it a privacy issue? So what are the data challenges so future AI methods would need to resolve before being able to apply AI? We can maybe start from that angle.
Yeah, I think that's a quite critical issue in China because in the power and the energy industry, most of the data are confidential. So that's make it very difficult. If you don't have a contract with the grid company, you can not do any related research projects. So currently in China, there is a new established called the National Data Administration. So they try to figure out the regulations that this specialized data, how to release it and utilized by the cross domains. I think it's become better, but still it's difficult to do the data sharing, especially this energy and power data across domains.
Ellie, how about Eversource?
That's true in the United States as well. This data is called CEII, Critical Energy Infrastructure Information, heavily protected data. And the role of regulation is to kind of find a balance between transparency and actually protecting the energy infrastructure from bad actors. We do have good examples of how this can be worked out. For example, Eversource and pretty much every other utility in the country is publishing their hosting capacity maps. They're maps that show areas of their system and how much available headroom they have to integrate green resources, to integrate large loads. One of the steps to enabling the stakeholders to make green decisions and deploy solutions. So that's one part of things. In terms of what's coming from a technical perspective, in sort of the interface between hardware and software, we have the utility's next goal, which is to digitalize the grid and kind of eyes on the grid technologies, as we call them. That could be the digital twin. And then a really important one is the advanced metering infrastructure, or AMI. Many utilities have it, many utilities don't. Eversource is now deploying in Massachusetts their AMI infrastructure, as are the other Massachusetts utilities. And what will that give us? Data that is much more consistent, much more clean, much more granular, real time, with much higher confidence. So a lot of opportunities there for machine learning and AI to kind of help the utilities take these, operationalize them, integrate them with their systems, and enable the green transition.
Yeah, the data access issue is a huge one because of the critical infrastructure protections, which go way overboard. I mean, it might have made sense, after September 11th, but it's not hard to come up with a representation of bulk transmission networks at this point. And there are a variety of data sets you can already pull together to replicate them. And we're doing so right now, and we're going to try to actually publish public representations only for the thermal analysis, right? Like, it's not a threat unless you get sort of into the stability realm. So that's probably going to be another question. But for the thermal sort of bulk representation of just power flow, it's not a threat. So we need to get rid of some of these guardrails, I think, so that we can open source more of this information. But this is why I think there is reason to be somewhat bearish that if we can't get around these barriers, it's going to be challenging, which is why I think the new initiative that EPRI just launched to try to sort of create a place for anonymization of the data is going to be so important. But I think the other opportunity is to try to develop protocols for taking realistic representations and then making them synthetic and not actually representative of the underlying network. And so we need better protocols for sort of converting realistic representations into synthetic, non-accurate ones that are still useful from a research standpoint.
Excellent, very important. This EPRI repository, when it's available, it's going to be potentially a game changer in this. Henrik, what do you think?
Yeah, I mean, I would agree. There are technical solutions to that, right? Synthetic data is part of it. Federated learning. We're building foundation models which are trained actually on synthetic data. And then you can take that model behind the firewall and train it with your own data, with your own private data. So I would say there are technical solutions to all of that. And it all boils down to whether the AI models provide significant value so people would actually do that.
Yes, that's a great point. Right. So let's talk a little bit about flexibility. It came up yesterday. It came up this morning in some of the talks. Data centers can be flexible. They can provide demand response. This can help the grid. This was mentioned. So when we say flexibility, we are broadly talking about data centers responding to what's going on in the grid. It could be the lack of availability of sufficient power. It could be maybe responding to available green power and other methods. So what's the potential for flexibility or demand response broadly? What does the grid gain? What does the data center gain? What does the community gain? So I'd like to ask about that. So maybe let's start with Tyler because he wrote a big report about flexibility, and then we can go around the panelists. Yeah.
Sure. Yeah, it's fascinating. I've worked a lot in transmission planning as well, and I have a lot of colleagues, and they're doing really good work to try to expand the transmission system. And the whole notion is like, we don't have any headroom left on the system. and it's just bunk, right? Like, we build the whole system around about these very occasional system peaks that are driven by polar vortexes and extreme heat events. And in every other hour of the year, the system is heavily underutilized. And in fact, on average, the system is only utilized at about 50%. So like in any given hour, on average, half of the US power system is not used. So we build the whole system around the peaks. We're really talking about like 50 hours a year, give or take, depending on the system, maybe up to 100. But if a new load can be flexible such that it reduces its draw from the grid during these occasional extreme weather events, then we can add massive amounts of load with the existing generation fleet. And there will be localized transmission bottlenecks for sure. So, and none of this is to suggest that like we shouldn't keep investing in transmission and generation. But what we need to, I think, the critical task right now is to slow this push towards massive fossil fuel expansion and extending the lifetime of these coal assets. And so I think demand flexibility gives us a tool that can buy us time and save us capital while we scale up these cleaner resources. And that, of course, includes existing renewables and storage and long-duration storage. But we are going to need some sort of clean, firm research, which is also what Varun emphasized yesterday. And so whether that's enhanced geothermal, nuclear power, or other resources. And so I think we're going to really need this to buy us the time and save us the capital to scale up those, and bulk transmission, I should say. So happy to dig into that in more detail.
Thank you. Ellie, how about the utilities? Are utilities ready for more flexibility?
I would agree with Tyler. Flexibility is what unlocks the potential for us to make efficient decisions in terms of how we spend our capital, in terms of our O&M, right? If we have a large load and we know it can sort of back down on its consumption, then we know how to invest in the system in terms of, you know, does every electrical asset, does our equipment have the capacity it needs to push that power? If we have a contingency, like a major event, how can we tweak the system, close and open ties, and make efficient decisions? What is really important to utilities, and I think the generation side as well, the markets, the independent system operators, is that flexibility should be bidirectional, right? So we're talking about the load centers being a large load in the system that needs to somehow match. We need to match generation to feed it, and we always talk about, well, can it back off? Can it not ask for load when the system is stretched thin? And we also hear a lot about AI facilitating interconnections of distributed resources and of large loads, of AI potentially being able to batch run scenarios that could sort of say, how can you be prioritizing the interconnection queue if you have the capability to really quickly and in multiple steps back off your consumption? But it really should be bidirectional, especially when we see a future of many non-dispatchable renewables that we want to integrate, right? Yes, disappear when you're asked to, but also, you know, don't disappear in a way that is unpredictable, and then the green power doesn't have where to go, and the system could even become unstable from too much generation, too low demand. Or said otherwise, is that something that AI can do, right? We don't have a great capability right now forecasting exactly how these new types of loads trend. Maybe that's a new use case for AI.
Joey?
Yes, we are doing some research project on the flexibility that we think the data centers has the potential to provide some flexibility in terms of demand response of the grid. And but this just currently cannot happen in China, because on the one hand, this AI data centers currently is being built very expensive in China. So once people invest GPUs in data center, they always want 100% usage of these expensive resources. And on the other hand, there's no existing mechanism in the power market in China that if any data center can provide this flexibility to respond the grid requirements, there's some rewards to them, right? That market just has not yet available in China. But people are talking about and trying to build like this virtual power plant mechanisms so that resources can be aggregated together. And I think that is a quite hot topic in China, and people are building this current.
Go ahead. Yes.
A couple things there. Thanks for that. Well, first, maybe it's helpful to just, when we say flexibility, what does it actually mean for like a data center? So in my definition, that encompasses on-site power and storage. And we don't want this to just be like tier 2 diesel. So that's what we need to be careful about, is that flexibility just ends up meaning running diesel a lot more. But we, especially with more geographic diversification for the AI specialized training centers, data centers, it enables now more access to cleaner sources of power, I think, than we've traditionally seen in just like the Northern Virginia tier 2 diesel backup solution. I know there's a lot of interest right now in various forms of storage for data centers, including thermal storage. So there are a lot of interesting opportunities there. But this also includes spatial and temporal flexibility. And because the training workloads are more batchable and deferrable than legacy sort of real-time on-demand cloud computing services, this unlocks a lot of potential. And so what we're talking about with these peaking events, right, are like 2 to 5 hours. So we're talking about deferring a training workload by a relatively short period of time. And it seems like it's doable, and I know that's part of your research, is sort of figuring out how to do that in a way that doesn't have an impact on the quality. So the other thing I just want to say, I think there's a lot of confusion about this notion that like the data centers are running at 100% utilization. So it's true for the servers, but the stat that Lawrence Berkeley National Lab used in their latest energy data, so the data center energy usage report, which was congressionally mandated, was 50% utilization of the interconnect nameplate rating for the data centers on the grid. And so there's actually like a ton of headroom, and part of that is because traditionally, like, the data centers have substantially oversized their interconnect requests to the utilities, in part so that they could have optionality for expansion over time, and also because it just provides more redundancy. And that was during a period of like abundance, right, where there was a lot of headroom on peak on a lot of systems, and frankly, it was a symbiotic relationship with the transmission providers and the investor-owned utilities, because it allows them to pad their rate base, right, by just rate basing more network upgrades and more new generation capacity for the data centers. But now, we're obviously in an environment of scarcity, so we have to get more utilization, I think, out of those data centers. And so just so we're clear, like, when we say it's 5 nines, like 99.99% uptime, that is for the customer-facing service on the server. Even the servers aren't running at 5 nines. In fact, we don't have good data on this, right? But like the estimates I've seen are that the servers are running at maybe like 60 to 70% utilization. And in fact, you wouldn't want to run them anywhere close to 5 nines because they would overheat and actually make them less efficient. So there's just like, and I'll just say, I've talked to a lot of utility regulators about this, and they're completely confused because they've been told that these data center loads are running at 100% utilization, constant in all hours, and have zero possibility of flexibility. And I'm hopeful that we can sort of change that narrative and help the regulators get the tools they need to sort of put these new service tiers in place.
This is an interesting warning because the utilization means different things, right? So, and here we are talking, people are talking from different backgrounds, different communities. There's the tech side, data center side, there's the power grid side, there's the customer side, and utilization can mean very different things. And Tyler's mentioning that, like, when you look at the grid, there's a lot of underutilization. When you look at the data center, there's still a lot of underutilization by design. And then what Junwei is saying, that, which is also true, GPU clusters are heavily used because they are expensive. The companies don't want to, providers don't want to underutilize them. So it's important to understand these differences and design flexibility, the potential accordingly. And Henrik, I'd like to hear your comments on flexibility, and maybe you can also add a little bit on whether AI can help with this flexibility journey, I would say.
So the second part of the question is pretty simple. I'm sure it can. But let me just say one thing about the flexible load of data centers. Of course, there is opportunity. It's again a question of what is the cost of that demand response, and not all data centers are the same. So if it is an AI hyperscaler, probably going to be higher. If it's a legacy data center, yes, you're going to have 50%. If it's more, so you're going to find very different types of data centers with very different characteristics, and some might be very flexible to afford. And so that's something to keep in mind. And the other point I want to make on this one is super important. You can virtualize computation, of course. That's very easy. We do this all the time. But you cannot virtualize data. So you would have to figure out whether you have the access, so your GPUs won't starve of data, et cetera, et cetera. So these are, I think, all things which can be solved, but they are somewhat more specific to the different data centers, what they do, what are the service level agreements, et cetera, et cetera.
Mm-hmm. Yes.
Can I say one thing about the service level agreement, just really quick? So I get sent these charts, and they're about like the value of lost load for different customer types, right? So it'll show like a comparison of residential customers versus small commercial customers versus data centers. And it'll be like $3,000 to $5,000 a kilowatt hour, or if it's megawatt hour, for residential. And then for the data centers, it'll be like 2 orders of magnitude higher. It'll be like 500,000. And what's actually going on there is that they're accounting from a system level perspective the value of the lost load for the data center based on a private bilateral agreement between the data center and their customers, which for them matters. But like, take an example. So if I signed a contract with you right now that said, if my power goes out at any time this year, I will pay you $1 trillion. Then all of a sudden, like, my home is like has the highest value of lost load of any on the system, and I don't expect like my Duke Energy, my service provider, to like account for that and how they think about value of lost load. So anyway, I think there's a lot to think about here in terms of value of lost load, how we account for it from a system value perspective, and also, by the way, how that's going to relate to curtailment prioritization when we do have load shedding events, because I think that's another critical consideration.
Thank you, and I'd like to spend a few more minutes on challenges in implementing flexibility, both from the data center side and from the grid side and from other angles, if relevant, for AI and AI data centers specifically. I mean, we talked about flexibility potential. If we have large loads like data centers actually accommodate for the peak times, that could mean that we don't have to add coal and gas plants. We can use the available grid. So there's a lot of potential, but what are some of the AI-specific challenges, like I was saying, both from the data center and the grid side? Or maybe I can ask this, why don't we just do it tomorrow? Maybe we can start with Ellie this time.
Why can't we do it tomorrow? That's actually a great segue to how I wanted to structure my answer. The biggest challenge, I think, is the workforce. I don't think that we could do it tomorrow because we don't have the workforce, at least not in the energy sector and the utilities. In my opinion, the ideal future would be a future where these AI, these ML solutions are not black box tools to the utility operators. Can we build it? Can you have something that batch run solutions for them and exploits the flexibility and tells them, here's your top 3 options. No need to kind of scratch your head for the 100 options that you have as the system gets more complex. Yes, but the ideal solution would be that it's at least a white box tool, a tool that they can interact with, they can do specs, maybe they can't build it themselves, but they really understand how it really works and how every input influences the decision and the output that it spits out.
Junwei, what do you think?
I think in the near future, maybe we should take most advantage of this AIGC and large language models. I think the most advantage is it make the knowledge transfer, knowledge sharing very cheap and convenient. I think that's is a major issue in energy industry, or most of the time the people working on the new energy sources, they know nothing about the grid, and people work on data centers, they know nothing about the new energy side. So if this knowledge transfer, knowledge sharing could be done in a very efficient way, I think the all of the productivity and organization efficiency should be improved. On base of that, maybe we can start to solve this cross-disciplinary issues.
Thank you, thank you. Henrik, what do you think?
Maybe a slightly different angle, but goes back to your previous question as well. So I think as we are building out, as we are expanding, right, bringing in new data centers, there's obviously a huge opportunity to make good choices and bad choices. And so I think AI can play a huge role in helping us to make better choices there, right, through accelerating the whole interconnection process, looking at all kinds of different options. Most data centers, they don't have to be in a particular place. They can be in different places. There are different options. There's thousands and thousands of scenarios. There's a different environment where they would be connected to, which means the conditions going to change, and in some cases it's much more amendable than in other cases, and very often, that is my limited experience in that, we're not even looking at all these options. And why aren't we looking at all these options? Well, because we're not using AI, I would argue. That's where AI could help, yes.
And maybe a quick follow-up on that. You have worked on foundation models. There's a lot of work focused on large language models right now, and then there's the general intelligence, the AGI is coming, and agent-based AI, etc. So it seems like the world of AI is going very fast, but do you have a feeling for, like, for GRID, all of these models should be explored, or one of them is more relevant? What type of AI? And Tyler kind of started with a warning about getting too much into the fun side of AI and forgetting about fundamental problems. Do you have any sense for that?
Yeah, so let me just say, when I talk about foundation models, I do not just mean large language models. So large language models are foundation models, but we have many more modalities. In fact, that is where I see a lot of opportunities to build foundation models. And why do I think foundation models is a really good idea? It is because I've been working in this for a long time. Our main issue always has taking our existing bespoke AI models and scale them to different grids, different locations, different applications, different customers. And so we need something much more scalable. And it also is key for overcoming some of those data challenges. That's what I'm thinking.
Thank you. Yeah, go ahead.
Well, so we haven't talked about one application. So Sam Altman, right, he believes that his models are going to help solve the problem of fusion power. And like he's heavily invested in Helion. Like there are big investors that are very, very bullish right now on fusion. Commonwealth Fusion just announced a site in Northern Virginia. They claim they're going to have a commercial fusion reactor online within 5 years. That will not happen. Maybe it'll be 10 or 15. But you know, you're talking about new foundational models that are more like physics-based and actually understand the science. Like, I mean, you can come up with all sorts of grandiose, like amazing possibilities for what could happen, but we're not there yet, and we have no idea when and if that'll occur. So in the meantime, like, we have to assume we're on our general trajectory with existing technologies with sort of incremental innovations, and that's what we have to work with. One other thing I just want to say about why we're not getting there, we just have to understand, like, the incentives that we give to the transmission providers and the utilities have enormous weight in determining the direction of the power system. And we oftentimes give them very poor incentives when it comes to innovation, adopting new methods that can get more utilization out of the existing system, because oftentimes their fundamental incentive is to just build more capacity.
That actually is a great tie-in to what I was thinking of asking next. And as the last question, we talked about collaboration in this summit. The summit itself is a collaboration, right? So between different stakeholders, different types of participants from different sectors. What does good collaboration look like between government, academia, industry, utilities, tech, and power grid? So we can't just say we collaborate, let's collaborate, but what's a good example of this, if any, or what are maybe some challenges that's preventing good collaboration? So we can just start from this side and go around the room, and that will be the last question. Go ahead.
I mean, successful collaboration relies on mutual interest, right? So in a way that we all can gain from working together. And there are examples, of course, open source projects, Linux Foundation for Energy, etc., right? They're doing great projects. And so I think it is about trying to find a common base, a common ground on which we can build together, and then everyone can go off and do their own thing. Then typically I've seen collaboration working very well.
I'll offer a slightly different perspective. We've actually designed an adversarial process for making big decisions for the trajectory of the energy system. And there's no better example of this than the quasi-judicial nature of the proceedings that occur before public utility commissions and FERC, where these decisions get made. I mean, if you want to go look at this in real time, right? So there's a huge proceeding happening in PJM right now around this whole concept of co-location of data centers with generators. And a couple of days ago was the comment deadline for all the interviews. So there are like 40 sets of comments, trying to figure out how and part of it's about how to enable these flexible loads. And so you have to do that because we need like intervener rights, and we need it to be insulated from undue influence, so it has to be quasi-judicial. But it also, like, we are putting basically an impossible task on the regulators. Like, they just cannot digest all the information that's being put at them. So let's apply AI agents to like help the regulators too, by the way, because there is no way that, and by the way, some of these regulators at the state level, they not only have to regulate the power system, they also are supposed to regulate water, telecom, and other transportation. And it's really, I mean, it's crazy. Just by the way, like, it is insane that we do not have at every state level an energy dedicated utility commission. Like, that should be a high priority for a lot of states. So I'll pause it, but it's just to say that like, we have designed adversarial settings, and we need to figure out a way to like both collaborate, but also make those adversarial settings work better.
Thank you. Ellie?
Yes, all stakeholders have a common goal, and that is the basis of collaboration and cooperation. But what's important is also for all stakeholders to understand each other's constraints. So coming at it from the utility perspective, what are our constraints? You heard a story about, a very, very aggressive timeline of building something out and interconnecting it to the system. And that's not how a utility can work, right? A new load that comes in, a new resource that comes in, different types of system needs that it creates. And we can talk about how we calculate those needs, but it does create new needs. So what if we need to build a new station? That is a very, very long process between permitting, between our regulators, very, very long process. So how to understand what can the industry do, what can these stakeholders do that want to build out data centers, that want to build out green solutions, and what can the utility do because of how it's regulated. What else does that mean for the utility, and why the utility is not purposely being a bottleneck in many processes? It's how we regulate it. Why? Because of how we make our money. We are a private company, but we make our money through the rate base. That's why we go to our Public Utilities Commission, say what's our plan, get approval. That's why we are, if we're honest with ourselves, a little bit behind and kind of slower with accepting and adopting new technologies, because we need it to be tested out before we go spend money on it. That is our ratepayers' money.
Thanks, Ellie. And Joy, your thoughts on collaboration, perhaps also international collaboration?
I think maybe not international. My thought in China, I think any collaboration in this area should be, at least at this moment, driven by the market requirement, because the energy and power industry, the trading market is a hot topic because it's not mature in China. So I just give an example that the National Administration of Energy just released a policy that all the grid-connected new energy has to enter the trading market starting from the June 1st this year. So this invokes a huge discussion about the pricing, what's the price, future price of new energy, and now AI become a hardcore requirement, right? Using AI, you can forecast the demand and the resources. You can forecast the price. And with that requirement, we build collaboration. I think in China, currently is a more meaningful approach.
Thank you so much. And I'd like to thank the panelists once again. So I don't want to be standing between the room and the lunch. So we'll have lunch and then we'll be back here at 1 p.m., right? Thank you.
If the panelists please remain at the front so the photographer can take a photograph. Thank you.
Wow, but it's like, wow.
My grandma used to tell me stories.
I should. Okay, it's so
how she built a bomb
different.
in
I grew up in
California.
California, so it's just the whole atmosphere and everything.
Wow.
You know, it's just like a Mediterranean climate. Here it's this temperate climate, so it's just a big contrast.
Yeah. How are these goalposts even enforced?
So,
I gotta go.
Right. Sure, yeah. Yeah, but how you enforce the regulation. Right. This is a big issue. Yeah. Right. Like it's, I don't know. She was telling me that's, yeah. Those are in place somewhere. Where, like, the regulation, like, example you gave, is that, like, in place? Oh, really? Oh. Okay. Right. Yes? Yes. It is. It is. But it's like,
Yeah, well, right outside.
I just get nervous about
Virginia.
self-regulation.
Yeah. All the data centers. Yeah, that's what I'm looking at. That's out my window. Yeah.
Yeah.
How about yourself?
Yeah, I teach here. Yeah. I'm originally from California.
Yeah.
And then kind of like did bi-coastal ping pong
It's
back
like,
and ended up here. I've been here since 2000.
I guess, yeah, I don't know. But the government regulators, I just have to like look through the code.
You are a tenured member of both coasts. Which one do you like more?
Do that at scale. So.
Which do I like?
I don't know.
Yeah, the two coasts.
It's impossible to answer that question.
I know.
One thing I'll say is California will always be home. You just like, it's just ingrained in me. And so it's always, but it's home here now too.
Yeah, I mean, for so long.
What?
so when it's like 5 minutes of the car, when it's like, just a minute.
Hello and welcome back, everyone. I'm very excited to announce our final panel of the day. This panel will be on AI for global sustainable development, focusing on technology, policy, and impact. This session will explore how AI can address global sustainability challenges, including climate change, resource management, and smart cities. I have the pleasure of introducing our moderator, Suchi Gopal, Professor of Earth and Environment at Boston University. Please join me in welcoming Professor Gopal and the panelists that she'll be introducing.
Okay, I think you're all exhausted at this point, having heard a lot of different things. So I try to talk to our panelists, and we really want to bring people back into the equation. People meaning not engineers, not people in utilities, but rather regular people like you and I. So I want to cover a few things that were not done in the talks today to make it more real. So I want to read out some AI in numbers statistics, then talk about AI in terms of serving everybody in the world, not just the data centers in the US and things that we've been talking about, but rather in the context of SDGs. How does it help women in third world countries or developing countries in terms of their access to energy and water? Things like that that are much more real. Or how does somebody in Indonesia deal with floods, which are more frequent due to climate change? So we also want to talk about some examples of some of the LLMs that people have talked about, ChatGPT models. I just had a conversation here which was very interesting. So I want to talk about countries and their sovereign rights to using LLMs for developing and dealing with their climate and sustainability. And I have the experts here to talk about it. And obviously, education and research, how do we move forward? How do we collaborate, which is one of the things that was raised in the previous panel. But rather, I would like to focus on how does it influence our teaching? And can we come up with some notion of a convergent science that brings together all the people in this room to come up with new themes and ideas on how to move forward, given the fact that AI is pretty much part of our lives. So in terms of statistics, I wanted to give you a few things. The previous training of LLM, ChatGPT 3.0 model, just one training of it can power 130 homes in the United States for one whole year. That's the amount of power it consumes. We talked about the fact that things are becoming more efficient, things are becoming much more optimized and so on. But in reality, the need for energy, the quest for, the thirst for energy, the thirst for water is going to be there with us. Water is even more surprising because it requires 148 million tons of liters of water per day in one of these large data centers. So if you can think of taking it to sovereign AI and having countries of the world, including Kenya or Nigeria or Brazil or India, develop their own AI, their sovereign AI with their culture and their language, because they don't want to lose any of their culture being overtaken by ChatGPT, how do they go about doing it? So given this is the backdrop, I want to first go around and have the panelists introduce themselves, and we have a set of questions for each panelist. Maybe we go with 1 or 2 rounds. So obviously, this is pretty exciting because each one of them brings a different expertise. And we have youth here, so that's very exciting. Youth is the promise of the future. So we have 2 of them here that are going to give us their opinions on what it means for the next generation. Over to you, yes.
Great. Thank you so much, Professor. So good to be here. My name is Hassan Faruqi. I am the Executive Director of the Boston Climate Action Network, or BCAN. And BCAN organizes residents across the city of Boston to advocate for city and state level policy action. And in the last 25 years, we've successfully gotten past lots of different laws and programs at the city and state level, mostly focused on buildings. And so today I also get to serve as a side gig as a regulator for the City of Boston's Building Emissions Reduction and Disclosure Ordinance Review Board, and get to work with all of our large building owners on making sure they reach net zero emissions for their buildings, which are by far the biggest source of emissions in the city. I serve on the board of Built Environment Plus on the green building side. And perhaps most significantly, I went to college right here at BU, so it's good to be back here. Thank you.
Thank you, Suchi. Nathan Phillips is my name, and I'm a professor here with Suchi in the Department of Earth and Environment at Boston University. And I'm an ecologist, and ecologists look at systems and try to make connections and find out what's working and what things may not be working. And my evolution as a scientist has been to look at forest ecosystems, and then by virtue of living in this big city, start to think about the ecology in cities, and then the ecology of cities, including the infrastructure, the utilities, the green infrastructure, the natural systems, and the built systems. And that was my entree into the world of utilities. I did some studies that showed that the gas network has leaks in it, and that led to looking at how gas and electric utilities are connected together. And so fast forward until 2022, I became elected as a member of a body that advises the New England grid, the electric grid, called the ISO New England. 6 states of New England are are governed and regulated by this grid manager, and I have a little bit of an indoor look at that. And so when it comes to AI, I've seen what has been discussed and so much of what has not been discussed. And primarily, going back to Suchi's introduction, the input of regular people, ratepayers, and residents needs to be much more elevated than it is, and I look forward to the conversation.
Thank you for having me here. It's a great honor to be in this panel with the greatest panelists and the moderator. My name is Zhao Ke from China International Capital Corporation. It's a CICC. We are one of the largest financial institutions in China, and I work for the investment bank. But other than the investment bank, we have our largest research house. The research house regarding the AI and we call the carbon neutrality, green ESG. We did deep research. We published 2 books, which is quite we would say quite influential in Chinese market, which is one is carbon neutrality economies, the other one is AI economies. And it's already have an English version. Hopefully we can have a discussion in the future for that book. It's from our house view, our CICC tone. And also we have our private equity side. It's one of the largest direct investment in China. It's about 80 billion US dollar equivalent to the RMB. We focus mainly in the very diverse area and many areas involved in green and AI, especially in the green. And last year, CICC has a very happy to have a joint venture fund with MNCs, different MNCs. Those, especially in the automaker, they are fully involved, have green and ESG, and also those MNC really wants to deep into the China green industry. And through the joint venture fund, it's easily to see all the different industry. So the learning curve will be very deep. And for me, I'm from investment banking, so we not doing the equity transactions, but also we're doing bond issuance, and we will talk about later regarding the green bond, regarding the financial instrument in the capital market. Thank you very much.
Thank you, Professor. I am Rakib, and I come from the United Nations Foundation based out of Washington, D.C., as well as the climate and sustainability startup space. I've been in it for a number of years with, it used to be a high school club back in the day, which is now a startup and an org, a youth community per se. My friends and I, back in high school about 5 years ago, founded Climate Cardinals because we realized a distinct linguistic disparity in the climate education space. So to say, 90% or so of climate information in the world today, including research, documentation, and all, is published in English out and about everywhere. However, if you notice, the populations that face the worst of the climate crisis just so happen to be non-English speaking populations in much of the global south. So this very niche linguistic disparity is something that we began to tackle just by translating climate information and research for our friends and family back home, for most of our founders kind of coming from international backgrounds. And we quickly realized that we were not the only kids in the school feeling the same way. And a lot of kind of volunteers stepped up, a lot of students showed interest, and it slowly grew from a school club to a local community, to a startup, to, I believe, an established org of some sort today. And we have over 16,000 volunteers in over 135 countries with 33 chapters across the world. Today, we've translated over 3 million words of climate translations, climate information, in over 105 languages. And it's been an incredible journey for over the course of past 5 years or so. And today I'm here to provide a little bit of a youth insight. Thank you, Professor. A little bit of a youth insight on how you can bring out practical, measurable impact into the real world without a degree. I probably am one of the only speakers without a degree yet. In about 2 weeks, I'll be graduating, so I'm excited for that. But other than that, yeah, I am very passionate about the idea of youth involvement in the policy and the sustainability space, where it is pretty much non-existent, unfortunately, and a lot of the world is headed by youth. Youth is the very demographic that is always up for change, is always down for the uncomfortable situations, and we I believe, are a demographic that is comfortable in the uncomfortable. And going out of your comfort zone is something the youth is very comfortable with. So it is very much a demographic that can push for measurable impact and change from status quo that we live in today. However, the very demographic that's not really being tapped into. So a little bit of insight on that front. And my work with the United Nations currently is in research capacity. I'm a research lead working at the very intersection of AI and the sustainable development goals, working with equity and inclusion across the world, from the global West to the global South and everywhere else across the 193 member states. Thank you.
So now we'll go around having each one of the experts answer questions that, you know, their expertise in. So the first question, Hassan, is to you. What role can AI play in the development as well as the governance of smart cities to optimize energy efficiency, mobility, and urban sustainability? I know we talked a lot about efficiency and optimization, and all the engineers had various perspectives. I want to talk to you, or I want you to respond like an economist from the supply side and the demand side.
Yes, thank you. Yeah, so I am an economist. I'm not an engineer, to the disappointment of my parents, but I am, I always think about cities. Cities are so critical because, first of all, cities actually have more power, in some cases, to regulate greenhouse gas emissions than even the federal government. Because when we think about where most of our emissions come from, a big chunk of it is buildings and transportation. And it's the city governments, town governments, who get to decide what gets built, where it gets built, how it gets built. And so when we think about, you know, how do we make AI a part of this, right? We are already seeing it right here in the city of Boston. One example I really love is around traffic. Do we have any fans of traffic here in the house here? We don't. And that's the oh, we have one person. Okay, well, that's great. So you won't like this, but what we have in the city is some of the worst traffic in the world. And many of you are nodding because you know this a little too well. The thing with so much of this is it actually starts in a few very specific areas, these intersections. So what the city is doing in partnership with Google through this thing called Project Greenlight is to use data from all of the traffic light cameras to optimize or to analyze traffic patterns and then to optimize the timing of those traffic lights. And they've been able to actually achieve 50% reductions in traffic congestion through using this program. Google says that this whole program across all these different cities has actually accomplished a 10% reduction in greenhouse gas emissions. That's nothing to sneeze at, especially when you're thinking about this is just one particular intervention. There are so many others that you could think about, particularly around things like optimizing the use of energy and electricity so that we don't have to use peak power plants. Those are some of the dirtiest power plants. There's actually one not too far from here in the Longwood medical area. And for those who don't know Boston, we have a whole bunch of hospitals and healthcare clinics clustered in a small area. They're really energy intensive. And the peak power, which is only a couple days out of the year, in that power plant uses diesel generators. We don't want to have diesel burning generators, especially not in a residential neighborhood. But if we can distribute the energy demand across a larger set of hours, you can actually reduce the need to have those peak demand generators in play. So this is all exciting, right? But all of this, of course, has to be taken in the context of the tremendous energy and water use associated with using AI. And we know, I mean, a ChatGPT query, for example, is 10 times the electricity use of a Google search, according to some estimates. And that's why you're seeing emissions continue to rise as a result of the demand for AI, right? Microsoft's emissions have risen 30% from 2019 to 2023. Google's emissions have risen 50% from 2020. I mean, and that's, you remember 2020, we weren't even using AI that much. So as the demand skyrockets, we're also going to see emissions associated with it skyrocket. But the challenge, I think, for us as regulators in a city like Boston is that the data centers, and as a result, the emissions from AI, are not here. Because data centers are really big, they require a lot of land. Land's pretty expensive here, and we don't really have a whole ton of it in the city. So then it ends up going out into the suburbs, into rural areas, and into developing countries. And yet, so much of the usage of AI is happening in a building like this one, and certainly is happening in cities like this one. So it's a challenge that I think really eludes city government from a regulatory standpoint, but requires a very important and strategic regulatory approach, because otherwise we are going to make certain optimizations over here and reduce emissions, and then create so many more emissions on the other side that we wouldn't have really accomplished anything. And of course, I mean, this is just emissions. This is to say nothing of the very real water impacts that come with the water cooling of data centers. We don't notice it as much here. We have a lot of water in Massachusetts, but I grew up in Colorado, where water is not so plentiful. And you're already seeing hugely contentious fights over water just here in the United States. So these are things that have to be taken into account as cities deploy AI, even though the cities may not actually have the jurisdiction to regulate the use of those buildings. But I'll close with this. The law that I get to be a part of regulates buildings. And that's exactly what we can do at a national level to reduce emissions and water use from data centers. And it really has to be state and national levels, because, as I said, the data centers are not happening in big cities like Boston and New York that have laws like this. So we do have a framework that we can employ for something like this, and that's exactly what we need to do sooner rather than later.
So I'm going to ask Nathan a question that he is more than an expert in, which is, we talk about AI and ethics and groups of people impacted with housing crises and how to get them, coming off of natural gas and so on. So what do you think is happening with the marginalized communities in places like Boston? How do we sort of address what we know in science, and how do we sort of, go about addressing these really troublesome issues? Because it involves the ethics and the governance.
Yeah, great question, Suchi. And I'm going to push back to start to say, I'm not an expert. I'm just asking questions. And I want to thank my fellow panelist, Hassan, for teeing this up really well, because you talked about those peaks, whether they're peak demand in traffic or peak demand on the electric grid. That's one of our biggest problems in terms of polluting largely environmental justice communities. And they're among the most low-hanging fruit for us to be able to actually solve those problems. But in my inside look these days at the electric grid, the regional grid, at least in New England, and the meetings that are had there, we're not seeing it. I'm not seeing the conversations that include people, that include ratepayers, that include communities. And the conversation is just starting, and I want to actually call someone out. Right over there, Tyler Norris gave a talk. Is that Tyler? At one of our recent quarterly meetings of this group that I'm in called the Consumer Liaison Group. It's a kind of a boring term, but it's a ratepayer communication and liaison group between people that pay the bills, the electric bills, and the board of this grid manager. And Tyler actually gave a talk at our most recent meeting. That's the first talk that I am aware of in this environment that I'm involved in that relates to this potential for us to exercise collectively what we call demand response on the grid. And as Hassan said, that is like shifting our usage away in time. Sometimes it's just 2 or 3 hours, just like gridlock on traffic where we can either reduce demand, shift demand, and that can mean the difference between a polluting peaker plant damaging the lungs and damaging the climate in a community. And so the conversations that need to occur sooner rather than later, because we're also seeing a perfect storm, frankly, of rollback of environmental protections federally. And I'm reading things about how coal, the dirtiest fossil fuels, is now being incentivized to get right back into the front of the line and power AI centers. I'm reading things about how outside of Memphis, Tennessee, in an environmental justice community, Elon Musk has built, with no environmental permits at all, 150 megawatts of gas to supply the AI data center, with hopes of doubling that to 300 megawatts. That's like a pretty full-sized power plant, utility scale power plant, with no regulation and no permit whatsoever. So we really have to start having the conversations at the level of grid managers, at the federal level, at the state level, and the city level, and it has to happen now.
So now we're moving topics, and we're going to go into China. So China being, we've heard throughout, China data centers, China's optimization plans, China's economy, and so on. We now want to ask the question, how is AI being interpreted or, across China's green energy and green value chain? Because that's pretty much part of the green financing scheme that you spoke about. So if you can elaborate, that would be great.
Thank you, Professor Gopa. And yes, thank you. I'm learning from all the experts. I'm not a green and AI expert. I'm more like a banker. But the thing is, I will, from the macro perspective, to see the China, what happened in China at the moment. China experiencing the structural change from the, we call the economy of scale to the economic of scale. So this model is changing. The reason is that in the past, in China, it's more related to credit driven, more to the real estate, and more to the traditional fossil fuel. Those all we call a traditional economy. And this is cannot sustainable. And China still highly depend from, from the energy dependence, still 72% of the oil and gas need to be imported. And also the credit-driven economic model is also, since 2017, we already realized it cannot last longer. So from that time till now, China right now is focused for the digitalizations, green energies, AI. So this is something we are doing. And China has some kind of advantage, I would say, is because we talk about economic of scale. The reason is that, for example, for the energy side, in China, right now we're the largest consumptions for in the world, but for the green energy, we already see the green energy, the installation of capacity, it's already 50%, which is it's already the highest point in the historical time. And also for the power generation in the green power, at the moment, it's already exists 20%, which means the green energy, the green technology have that highly related to the industry nature. It's not like before, like a fossil fuel, the traditional energy. The traditional energy, for example, for like a mining, it's highly related to the land. It's monopolized. The more you dig into the higher cost you will pay and the less the return you will get. But given the large scale of economy of scale, I always, sorry, my English, the green technology have the industrial nature. The larger scale, you will have the less cost in terms of the R&D, in terms of the infrastructure building, in terms of the whole value chain, establishment. So this is something we see in China. We can use this kind of advantage, and also it's similar as AI as well. So the AI have the negative impact with the carbon for the society, like carbon emissions. So how you adapt the green energy, the green technology together with the AI? This is something for in China right now. We are working on that. The negative impact might not be the case in the future because, like people said, it will optimize the AI, optimize the new technologies, transmissions, optimize the usage, the storage, also the what is it called, operational. So everything can be upgraded in the future. It's related to technology. Talk about technologies. China has the largest applications and has the largest scale of talents, not the largest scale of only the market, the talent. Every year, graduate school from the university, it's a 10 million every year graduate school student, and the 3 million is engineer, and they work hard and they're inexpensive. I would say that. So this is bring a lot of the force, talent force to the market, and also the application bring many of the data, not only the consumer data, also industrial data. That's also very can generate a lot of innovations. So you will see people talk about the China's speed because there's so many subsidized, so many. Actually, it's because of the competition. It's so severe. Everywhere, every single industry have a highly competitive, landscape. So it will create this higher speed of iteration. So all the product, like if we talk about each single unit of the storage, each single unit of a power station, that unit can be integrate and can be upgraded all the time. We already see the solar panel. We already see the wind power. We already see the EV cars, auto drive cars. So those are, it's very strong at the moment in China. So because of the competition and also the innovation. And maybe we will talk about later regarding about the financial.
Yeah.
Okay, I stop here. Thank you.
Thank you. So the question I have for you obviously is, how is youth, in your opinion, involved in addressing sustainability? Is the youth using AI in deriving insights? And yesterday when we were talking, you mentioned user interfaces and your expertise was developing such things. So can you elaborate on your experiences of bringing in youth into this field?
Absolutely. I would like to begin with the idea of youth being in the policy sector in general, or even sustainability. These aren't sectors that are traditionally you would hear about kind of growing up in career-wise. For example, I've told this to a couple of us earlier. Growing up, I was born and raised in Bangladesh up until 2016 when I moved to the United States. But till then, I grew up hearing about 3 possible career choices that I could have made. It was you either become an engineer, a doctor, or a failure, and I couldn't figure out which one to do. And I had to create a 4th door, and sometimes you might feel like you're in a narrow hallway with only 3 doors. You really can't go anywhere else, but that hallway is imaginary. It's put in your head by convention, and youth is that one, like I said before, the demographic that is not afraid, oftentimes not afraid to go against the grain, go against the wave and convention, and challenge status quo. So to say, all this to say that I was kind of able to carve a career in the sustainability and policy space. And well, I did study information science, and so my parents are, I guess, okay with it. But yeah, youth involvement in the space, if I had to speak on, would be Climate Cardinals is a great example of how we started our journey in the sustainability space and leveraged actually AI to further the impact that we began to have in the communities that we were having an impact on. We started 5 years ago in a high school, and then as we started scaling and gaining more volunteers and people and traction, we realized a lot of the translation work could be done by machines. People are not, as the technology lead and the former CTO of our org, I'm a big believer that humans were born to tell stories and not crunch numbers. Translating is just another form of processing data, and you're just crunching numbers at the end of the day. This is a machine's job, and your job is to tell stories. And to push that agenda, kind of that ideology within our org, what we did was create a pretty simple AI translation tool. However, some of the things to highlight which made it different and more suitable to our niche demographics that we were playing a part in was the fact that it took into consideration cultural context, regional relevance, and it was short form content that we delivered to these global south populations in vernacular, in their own languages. Because think about it, at the end of the day, if your target demographic is non-English speakers in the global south, it's highly likely they probably work 12 to 16 hours, 18 hours a day. Kind of coming from that environment, I don't know, if I come back home from a 16-hour workday of probably manual labor, the last thing I want to read is climate research jargon and 5 pages. Yeah, it's absurd. And something that I would want to read or even want to scroll through would be something I can personally relate to, something that very person can relate to. And when your expansion is across 135 countries, it's difficult to relate to everyone over there. So we began to collect regional insights and cultural context within our translations. We began to move away from the climate jargons and get to a more high-level sort of understanding of where things are going wrong. What is at a very individualized level, what can I do? How about I just reuse this plastic bag I just got from the grocery store? That at a very individualized scale is an action you can take from your own comfort of home. And these are stories we began to tell through AI-driven translations with cultural context and regional relevance. And it only helped us grow at a significantly faster rate in terms of volunteers, in terms of the community that we targeted. And it was only made possible by youth and our 16,000 volunteers who were previously just kind of translating or translators now are able to get those AI-driven translations kind of proofread. We still keep a human element to it at the end of the day. It is humans reading the paper and not a machine. And once they kind of proofread and the paper goes through, our final step is the distribution process. Or most of our distribution goes through either universities, localized universities, radio stations, which is I don't know if a lot of us listen to the radio on the car. You kind of just connect to Apple or Google Music and just kind of start playing your own thing. But yeah, radio stations having a big influence in a lot of the global south and a lot of other regions in the world. We've partnered with universities, radio stations, and government agencies. But at the end of the day, it's the localized individuals who kind of don't have access to a lot of those. They listen to stories from their kids, their grandkids. The one kid that goes to school in the community can kind of come back in a marketplace and tell stories. When we hear stories like these, for example, once in Nepal, one of our chapters at Climate Cardinals went out of their way to actually help with evacuation and relief during the time of an earthquake. And yeah, this was very recent, actually, earlier this year or so. And it was incredible and very fulfilling at the end of the day to see a very grassroots level impact in a land far, far away from where you started, use what you started to do better in a very hyper-localized community. And that was kind of our idea, is to go hyper-localized, is to go climate education is something we focus on. Language accessibility and language barriers is something that holds back innovation. It's holding back inclusion per se, be it an intergenerational inclusion from people of various ages, including youth, or inclusion across different regions of the world. So language barriers, eliminating them, leveraging AI, was a way youth, in our case, took the initiative to move forward towards a sustainable development goal.
That's very exciting to hear. I just had a trip to Belize a week ago, I think, and I came back and I was so inspired because for the first time we are able to use Landsat images. We do a lot of remote sensing and satellite imagery to look at change detection, land cover change in different parts of the world. And we are trying to work with them on nature-based solutions, which is working with them on preserving mangroves. The youth of Belize, I mean, they are so smart. We were able to fly a drone, a simple RGB drone, and of course we'll be flying more sophisticated drone also. But they were able to sort of immediately use this information and tell us exactly where did they see the changes happening at a micro, I would say it's almost like a sub-meter resolution. They knew exactly what the lay of the forest was, where exactly changes were happening more rapidly and not. These are the kids born with a computer or a phone in their hands. It was so easy to convince them to pick on something and run. So more power to the youth. So now, question back to you. I was going to ask you about things to do with economic policy. We talked about efficiency, optimization, and things from the engineering perspective. Which of these policies would work in terms of the state or the city sort of, levels that you deal with? Or should all these policies and regulations come from within companies setting their own guardrails, especially in the use of ethical AI?
That's such a great question. I mean, it really needs to come from government because government is the only entity that can actually require things to happen. When we're thinking about economic policy, I mean, there are really so many seismic shifts that will happen from artificial intelligence, especially as it continues to evolve from an economic standpoint, right? But a few that I think about a lot are especially the impacts on workers, right? You have so many jobs that are already starting to be automated. In some cases, people are able to keep their jobs and it augments or enhances the way they're able to do the job. In other cases, you may have folks who are actually laid off and their job might entirely be automated. Now, that's actually always been the case, right? Remember, well, some of you may not remember, switchboard operators, right, for telephones. That's not a job that we have anymore because that's now an automated process. You call someone, you get connected. So we're always going to see this kind of evolution in the economy. But this also has very real political effects, right? We remember, and some of you very much do remember, several decades ago, when the US started implementing free trade policies like NAFTA. And this allowed jobs to be moved from here in the US to overseas. Now, that created economic opportunity in other countries, but it also meant that places like automakers saw almost all of their manufacturing domestically dry up. And that led to real political resentment that really in many ways has brought us to the moment that we're in now politically. We can see the same kinds of political shifts happen when we have deep economic shifts as a result of AI or frankly any other thing. It needs to happen through government policy that puts rules in place to make sure that workers are protected and that make sure that yes, we can grow AI, but in a way that is smart and is ethical. Mm-hmm. There are so many examples we could name of places where we don't want to see AI happen, right? We don't want to see AI be used to help people build weapons. We don't want to see AI be used to fake people's identities and make them say things that they never actually said. We don't want to see AI, certainly I don't want to see AI, steal intellectual property and pass it off as its own. Those are things that we need to have clear guardrails around, and letting companies self-regulate is not a smart solution, because we've tried this in many other industries, right? Wall Street was like, yeah, we'll self-regulate, we won't do anything wrong, we promise. And then we got the Great Recession because we took the real regulations away. And we can't get into a similar situation with AI. We have to start with smart regulations, and we really are at the ground floor of this industry. This is the time that we've got to put some rules in place. But let's also remember, you look at some of the folks who are in, Congress and legislatures, they don't know what AI is. They don't know what social media is. So how are we expecting these folks to then come up with smart regulations for AI? We can't. And that's why we have administrative agencies that can hire real experts. And it's important from a legal standpoint that those administrative agencies are empowered to actually do this kind of regulation, that they're given the resources and the jurisdiction to actually accomplish this. Because otherwise, we are either waiting on folks who don't even have a cell phone to figure out AI policy, or we're doing nothing, and neither of those are good options.
That's an excellent answer. Thank you. Nathan, I wanted to ask you about research and universities and the role that you see in developing, students of tomorrow who are well equipped with this kind of convergent science of all the people in the room. How do we go about doing it when we are all solidly in one department or the other?
Yeah, great question. I'll try to keep it brief because I think we're running out of time here, and I want to leave space for my other panelists. Yeah, I teach a number of classes here at BU, and all of them touch on climate in some shape or form. And I have to show up and teach without coming in with doom and despair, given the predicament that we're in. And the good news is that I believe that the climate solutions are all around us every day. And I come into classes, and when I share that conviction based on evidence, I see my students respond to that. I'm going to give you one example, is this demand response. We have the power to really directly impact our grid and make it cleaner, more affordable, and more resilient. One example, there are these periodic peaks in which there's a red alert system on the grid because demand is far outstripping supply. We had one very famous one, December 24th, 2022, red alert across New England. The prices shot way up. The carbon dioxide shot way up over a period of hours. If you do the calculation, if all of the ratepayers that were on electricity reduced their consumption of electricity in that peak hour by the equivalent of turning a toaster oven down from high to medium, we would have wiped out the complete shortfall of capacity. We have that power to do that, and yet ratepayers don't even know this. We don't have the tools are there, they're not implemented by our utilities, by our regulators, to allow all of us to actually participate in this very powerful kind of a tool, demand response. I ask my colleagues, I ask my students, when you do a Google query, do you know that you can turn off AI if you don't need that? Or would you be willing to wait for that AI response a few hours from now? I ask my climate scientist colleagues, when you submit a big job for running climate models, could you wait like 6 hours or 12 hours? And my expert colleagues are like, I have no idea what happens when I submit my job. There needs to be a lot of education and empowerment of the population, including our students. And at BU and Harvard and MIT and Northeastern and Yale and UMass Amherst, we are all in on this data center called the Massachusetts Green High Computing Center. We could all be using that as a little sandbox and playground to do little experiments. What could we do to shave a peak? Students, faculty, staff, the whole communities, and across universities. I'm very excited about that as a climate solution.
Great. So the question to you is on, of course, the green bonds that China is sort of examining. And you were going to sort of mention a few things in terms of the initiatives that China has taken.
Yeah, thank you. Thank you for that questions. Yes, for the green finance in China, I think it's developed pretty rapidly. It's in the last 1 decade. It's only 10 years. But it's grow fast, and since last year, from 2020 until 2017 till last year, the end of last year, I think we already, for the green bond, we already issued more than 1,400 bond. But that bond, it's very diverse. We have all different type of that. For example, ABS, ANS, ESG bond, and also we call it blue bond, more to the ocean, and the carbon neutralities. So it's very, very diverse. And total volume, it's about 3 trillion RMB at the, since last year. So I think right now, from top to down, the regulator is already getting improved for their regulations terms. And also we need to adapt very much from the international standard. For example, what's the standard of the green? What's the standard of the green technology? So how you can solve the problem regarding the information asymmetries. So this is those technical part need to improve every year. So this is something. But from the market side, we from the credit-driven, or called credit-centric, that's all the model. Towards now, it's to we call it demand-driven, which is called the investor-driven. So you have to provide a product that investor willing to buy, to invest, and the issuer have the incentive to do the insurance. So the issuer at the moment, for example, the bond, the price we have, it's like 10 to 20 bips point discount for the price, which have the incentive for the issuer, the company to issue the bond, but also incentivize the company to using the green power, to using the green applications. This will bring the society going to move the right directions. So we will say in China, other than the bond, we see a lot of funds, like I said, the joint venture fund, the private equity side. Right now, people are using, we don't have to using a large amount of money, but you can using a fund, because if you doing a bigger merger acquisition, its decision making is very long. It's taking very complicated. So, but using a fund, you're using a small amount of capital, but you quickly into that ecosystem, especially in the green and also AI. That make the company have a more vision into different industry. I stop here, sorry.
Yeah, thanks. I was going to ask you, what are you most hopeful about in terms of technology? I mean, people have mentioned AgTech and FinTech and climate tech, and we talked yesterday about climate tech. So can you sort of tell us quickly what excites you?
Yeah, absolutely. I think the very aspect of technology that excites me the most is accessibility. I very much believe that the rate of innovation today in the Western world is the same rate at which the global South falls behind every day that we move forward. And I don't know, at least for me, I don't think that's okay. And creating equitable solutions that are accessible across the board is something that's very, very important. Today, we're creating very, very complex AI models that are requiring so much energy to everything, all other resources to power these responses and create incredible works of art in its own sense, which most of the global South have no idea about. While we're persistent on developing these models and technologies, I think it's important that we remember there is a whole nother world out there that has almost no idea ChatGPT probably exists. At parts of the world, it's a non-existent solution. While we are improving GPT 4 to 5 and 10 and 13 next in a few years, someone will probably ask, what is ChatGPT? And that's very surprising. So accessibility is something that I firmly believe in, and it's something that should be at the very forefront of development. A lot of development, when we learn, coming from a front-end developer sort of background, user study was a big thing that we've learned across 3 semesters in college. And one thing about user study that you learn is you study the user, and then you understand their requirement, and then you build a solution for them. That very last part has an inherent flaw where you build a solution for someone else. I think the approach should very much be you let them build their solution. I think the panel right before us kind of spoke, touched on this topic of allowing for, or hyper-localized solutions are only possible by people of that locality. And no matter how much you user study or analyze and understand, you're not going to empathize and understand with those that have lived experience in a particular setting, place, or life. And allowing them to build is something that's extremely important in innovation being accessible going forward, is something I believe.
Thank you all. I think we've run out of time, beyond time up. So I would like to thank all the speakers, and it was a very enjoyable session at the end of the day. So a lot of learning, and obviously we'll be interacting with the audience. Thank you so much.
Thank you to our panelists. If they could please remain seated so our photographer can capture a group photograph. And after this, we'll be proceeding with a 10-minute break before our closing remarks. Apologies for the change in plan, but because of time constraints, we'll be starting in around 3 minutes.
You have your triple lens camera, right? I got the double. Thank you so much. Amazing panel. All right, y'all stand in the middle. Yeah. Okay.
Wait, let's just do it. Let's just do it.
Yeah.
This is fine, right?
Yeah, we're on a time crunch here. All right.
Thank you guys.
All right.
Thanks a lot.
Thank you. Thank you.
Yeah, thank you.
Thanks, guys.
We're gonna start something first.
Thank you.
Okay. We lost some people, so we're gonna.
Yes. Thank you so much. Yes, great to meet you.
We'll send more people to PT and stuff. Yeah, sorry. You know how it goes. Yeah. All right, see ya. All right. We have an after party at Leverett House in your course, and I figured you're probably doing stuff. Yeah. Yeah. Oh, okay, nice. Yeah. Okay, yeah. We're going until like 8 p.m. Yeah. So. All right. Yeah, for sure. All right. Thanks.
Hello, if I could please ask everyone to make their way back to their seats so we can begin our closing ceremony. Thank you, everyone. I now have the privilege to introduce our closing remarks, which will offer a reflective and forward-looking conclusion to 2 days of vibrant discussion, innovative ideas, and collaborative momentum. I have the privilege of introducing our first speaker. Please welcome back to the podium Professor Aysa Közkan.
Hello. Thank you all for joining us here today in this beautiful and sustainable building. And thank you for staying until the very end. So I'd like to say just a few things. First of all, I would like to thank Jerry Huang and the entire Green AI Institute for putting this amazing event together for the second time in such short time. So I went to the Green AI Summit in October. I was impressed, and I wanted the center I direct, SAIS and BU, to be a part of it. And I think we worked fast and harmoniously. We worked hard to make this happen. And now the next big question is how to sustain this, right? So sustainability is an important aspect in everything, including in this great community, to continue to collaborate, to innovate together. So I'd like to say a few words. So as an introduction to myself, I mean, you know my affiliation, but I've spent the last 20-something years in energy efficiency of computing. That means a lot of different things, from hardware to software, from small-scale devices and mobile to data centers. My team has spent over a decade of research in data center power grid interface, essentially. I wish I could say that we predicted AI to have this boom, and that's why we were working on it, but that's not the case. But we still thought that something has to shift, and it's possible to develop the technology for data centers to be more grid-friendly, to be more sustainable, to allow for more green energy adoption. And you know, I guess now is the time to make it happen, because finally there's the opportunity. So there's a crisis in terms of the energy crisis, and a lot of panelists talked about this, energy crisis of AI. Crisis generally is a bad word, like nobody wants to have a crisis, but crisis is also an opportunity for innovation in general. And we have plenty of talent, and we need to just develop the right incentives, right technology, right collaborations to make this happen. So as part of the summit, what I took as as an attendee to this summit was that there are many areas of innovation, and just to sum up a few of them, we need more sustainable low-carbon energy generation, and that comes with also its energy storage technology challenges. Smarter and more resilient transmission. We need a smarter and more resilient grid. So overall, we talked about green AI here, but power grid itself is critical infrastructures with or without AI. So we need to make our grid more resilient. We need to match the decarbonization goals with the growth trajectory. Energy efficient computing is always a hot topic, and this is not going to change, because there's this quote that I really like: computing is like potato chips, there's never enough. So you always want more computing. There are excellent examples. Bob Brown earlier this morning gave the example from going from the supercomputer from a couple of decades ago to the cell phones we have right now, which are essentially similar to compute capacity of supercomputers of a few decades ago, right? So there's always going to be more computing. There's always going to be more efficiency. However, efficiency alone also doesn't solve the problem, and that's clear to the computing community, at least at this point. Flexibility has been discussed quite a bit. Flexibility in data centers, how to implement demand response, right? So this is essentially a low-hanging fruit as in addition to a longer-term solution for having data centers be better grid citizens as opposed to troublemakers in terms of creating an energy crisis, right? So we can use this opportunity for sustainable and equitable growth of AI along with a more resilient, decarbonized grid. And finally, all of these things can only happen with the right policy and market developments in place. So we do need to work together across different disciplines, across different stakeholders and communities. So I've been working on, like I said, over a decade in the smart grid data center interface. I won't spend too much time on this, but just a glimpse of a vision of what could be happening is that as opposed to thinking about these things separately, can we connect the vision? Smart grid can tell the data center when it needs more power, or smart grid can tell the data center when there's more green power available. And we can do this during emergencies, or we can do this pretty much continuously. And we worked on implementing this vision, and recently Tyler's report came out. Tyler was speaking at 2 previous panels. I recommend you to take a look at it, and this is really eye-opening because if you think about the opportunity in the grid, like if you are just a tiny bit of flexible for a very small amount of time over the year, you can already integrate more data centers, avoid expanding the fossil fuel source energy generation, right? And open up the pathway for renewables to get integrated, for energy storage to become larger scale, greener, for the grid control mechanisms with all this nice technology with AI to be in place, etc. So this is important. And when we say flexibility and demand response, there's a lot of things. This is just a taxonomy that we put together recently. You can go from like pricing programs to incentive programs all the way in the down to like how to implement flexibility in a data center. There's a research topic for everyone here. Like if you like economics, there's something of that. If you like control and optimization theory, or if you like machine learning, there's something of that. If you're a software person, there's something of that. So the problem has many different angles essentially, and it does require interdisciplinary research. And so what we built, what I want to show you just as a glimpse, is that a demand response software suite for data centers that does this. And we have been working on this. It has many angles. I won't get into like technical research details. But at some point, how do I get rid of that? Okay. Great. Thank you. Just waiting for the technical difficulty. Can we go back to the slide I was presenting? Thank you. All right. So we implemented a demand response prototype at MGHPCC, Massachusetts Green High Performance Computing Center, a couple of years ago. I should say at a cluster at the data center, not at the entire data center. It's very hard to convince somebody to give you a data center to play with. But we did get a cluster, and what we demonstrated was essentially, can we have the data center cluster follow a power signal? So before any demand response, there's a bunch of high-performance computing jobs coming to this cluster, and they consume some power. What we wanted is to follow a given signal that's changing at the second level. And these programs currently exist in some markets, in PJM, in Texas ERCOT, in California. Basically, these are regulation service reserves type markets that give you a signal that's changing every few seconds, and there are monetary incentives for data centers today to already do this. And so this is what we wanted to see, essentially, and we demonstrated it's doable at a small cluster. And the technology is essentially almost there for this to be implemented at data center scale. So this should be the vision when we think about data centers, not necessarily this specific signal, but data centers can be predictable, can be controllable, while meeting all the amazing use cases and all the performance constraints we users have on the data centers. So it's possible. Flexibility is a possible vision. And when we implement flexibility, we can help with demand response participation, having greener data centers with carbon-aware optimization. So in terms of the vision, the slide is looking interesting, but technical difficulty again. Essentially, the vision should be a framework that controls data centers, large loads, in addition to other loads of the data centers. There are electrical vehicles, residential units, industry, etc. More controllable, greener, harmonized, and more resilient grid going into the future. Thank you so much for listening, and looking forward to seeing you at the next event, whenever that might be.
Thank you, Professor Yoskon. I now have the pleasure of inviting Karen Clopton to the podium. She's the former Chief Administrative Law Judge for the California Public Utilities Commission. Please join me in welcoming her.
Mirban, shukran. Hallo, danke, bitte. Ni hao, she. Hello, please, thank you. Bonjour, s'il vous plaît, merci. Privé, posajuste, spasibo. Hola, ¿qué tal? Por favor, gracias. Muchísimas gracias. I also want to acknowledge and thank the original settlers, the Massachusetts, and thank them for being stewards of this land that we are convening on. So why did I choose to greet you all in the 6 languages of the United Nations? Because language is really at the heart, the core of the solutions that we need to achieve green AI. Those words alone, green AI. I said yesterday, many have called that out as an oxymoron. But language is important. I realized this morning I didn't need slides because it's raining and you can all turn around and see this view. And what do you see? Actual clouds. Those are clouds. When we say cloud computing, we're talking about acres of ugly buildings filled with machines. We're not talking about this view, but think about the language that is used, the cloud. When AI, which one of the speakers very aptly put, is just another application. It's just another software development. It's another tool. It is not human. When there are errors, they're actually calling that a hallucination. Now, those of you who have been following hallucinatory drug use, et cetera, experimentation, use for treatment for post-traumatic stress disorder, et cetera, that's not what a hallucination is. But that is the language that is being used. So the language that is being used is to elevate, right, intelligence, and to disarm, artificial, the cloud to obscure or obfuscate what in reality isn't that, right? So I have one thing I'm going to repeat that I want you to think about and repeat to yourself, and that is, what are the questions I should be asking about the language I am hearing, about the language I am using, about my own actions? Because we've learned over the last 2 days that it's important for us to educate others, for us to be educated, for us to advocate for others and on behalf of ourselves, and to act. And we can act. despite the flooding of the zone strategy of the moment, or as some would call by the oligarchs, the sum. You'll be hearing about the sum. I like to attribute the sum, and then you won't be saying, oh, that, you know, that woman got up there and she said, no, some people say, right? So language being at the core. Why did I choose those particular words? Because Sam Altman has advised, don't use those words when you're using ChatGPT or when you're doing anything that's generative AI. Another word, ask, what does that mean, right? Because can AI in this context be truly innovative, and what is it generating, since the data, as we learned yesterday also, they only have access to 5% of all data, right? So it's derivative, right? It's old information, and the algorithms move to the middle. Okay? So those of us who know and are trying to demystify this process, right, we're looking at the language. So he said, stop using please and thank you, right? So are we trying to humanize and demystify software programs, but now they're trying to train other people, right, who are using these software programs to be uncivilized in some ways, right? Think about that. If you start to eliminate please and thank you from your vocabulary because you can't use that, that's the thing that's using the energy. That's causing energy consumption. But really, another question to ask also came up today, and that is, tell me, is it an AI company, OpenAI, is that their main business? Or is it an energy generation company? Are they crypto mining, or are they selling energy, or promising, I won't use that energy at this time, so I'll sell that back to you, and I'll make more money that way than from my alleged original business, the crypto mining? Ask that question. Why are we looking at nuclear power? Is it because Sam Altman is invested heavily in nuclear power generation? These are the things I'm asking you to look at, because these are the things we've learned about over the last 48 hours. We've observed that AI will revolutionize the economy on a scale equivalent to the Industrial Revolution. Well, right from the beginning of the Industrial Revolution, scientists knew what science was at that time, which we're only looking at, a little over 100 years ago with the Industrial Revolution, that there would be global warming. What does this all mean? In our economic, academic, and political systems, we seem to be unable to promptly and quickly respond to this economic and technological revolution. If we don't properly collaborate, which is another word that I heard all day today and yesterday, right? That we should be engaged in cooperation and collaboration with each other. And in order to do that, we should be using common language, common terms, and think about what our shared values are. It's always good to do a little inventory about what are your values, Think about your personal values. I know what mine are. I have 5. Accountability, excellence, integrity, understanding, and open communication. Now, sometimes I get in trouble with the open communication part, but that's also called transparency, right? It's good to be straightforward and transparent. So what can you ask for? What's the question you can ask? What's behind all the doors? What does this really mean? We learned so many new words, right? Demand response. Now, as the regulator, obviously I know all about demand response and the grid and what's happening, but consumers need to understand how it works. The ratepayers need to understand how it works. We talked about the quasi-judicial nature. I think the administrative law judiciary is extremely important. Most Americans, certainly, that's their experience with the court system. We have to have transparency, due process, open communication. Otherwise, they can sell you the Brooklyn Bridge. And perhaps that's what's happening, that instead of all of us beyond this room collaborate, ask the important questions, we're going to be in trouble, right? Today, the People's Pope is being entombed. Writing from the perspectives of history, economics, and cultural criticism, many commentators have described this present moment variously as the unwinding, the great unraveling, or an age of decadence. Our late Bishop of Rome, His Holiness Pope Francis, who took the name of St. Francis Assisi. I'm from San Francisco, so that means a special thing for me. Observed that we are not living in an era of change, but a change of era. This change of era may be decades, even centuries in the making. In the vast scope of history, it is but the blink of an eye. It will pass. But in the moment, some of us feel like it's the end of the world, but it isn't. I find it helpful and even consoling to take a step back from current events, not to get engaged in the doom and gloom and the doom scrolling, but to be optimistic that this is temporary, that we can learn from our mistakes, that we can learn from this great professor who spoke before me about all the particulars of making demand response and the grid more efficient. But that begs the question, what is the business of AI? What is technology doing? Is it just creating demand to make money on the energy side? Let's not rush into all that. And if you heard me doing that when my dear friend Tyler was speaking, that's just another form of communication, right? So as an African American, we do that because we're cool. The French stomp their feet, and a lot of Americans who go to Broadway plays, they seem to do a standing ovation all the time. So we have different ways of showing appreciation, of communicating, right? But we are all global citizens. So when we talk about collaboration, cooperation, let's think about it globally. Global warming didn't just happen, and it's not and it is impacting the global south at this point in a terrible way. Because pollution and all of that migrates, right? And warming, the atmosphere moves around. So the nations up here, their bad stuff, their detritus is falling down here. But they don't want, are you talking about that? Ask the question, how is this happening? Why is this, right? Why are we here talking about green AI? It has to be a holistic approach. And that's what we've learned from academia, from industry, from regulators. We have the answers, but we must talk to each other. We have to communicate. The Earth is about 4.5 billion years old, and the human species has only been around about 200,000 of those years. The Earth prior to the Holocene era, yes, I was just at the Museum of Natural History at Harvard, so bear with me for a moment. The Earth prior to the Holocene era was not nearly as conducive to human flourishing, and most certainly will not be as we move into the next era, the Anthropocene. So I recommend that you stay open, that you ask the questions, that you be optimistic, that you communicate with each other, and don't just accept that things are difficult. Don't accept the surface answers. Ask the important questions, because you can educate, advocate, and act on an individual level and on a collective level. Gracias. Merci. Shukran. Shashi.
Thank you, Ms. Clopton. To end our event, I would like to invite back to the podium our founder and president, Jerry Huang. Please join me in welcoming him.
First of all, I want to say a big thank you for everybody who has been here for the past 2 days. We have to apologize for the technical difficulty, but as you guys might have seen on the slides, there's 303 slides that we have gone through so far. For whoever has their own PPT on computer, after 50 slides, it will go super slow. Now we've got 300 of them for the past 48 hours. So first of all, thank you everybody for coming. Over the past 48 hours, we have gone through over 50 speakers, over 400 offline participants, and over 6,000 views on our website. This has just been incredible. And yesterday we have some concerns if we're going to fill the room today. Well, my feedback was we have ran out of chicken and salmon for today's lunch. So I guess you guys enjoy our our offerings from our event. So, before I go into my real talk, I just want to say again a big thank you for Professor Aisha Koskun and the Boston University Center for Information and System Engineering for the whole organization and support. Thank you. And definitely, we also have a big acknowledgement to all the sponsors from Harvard, including the Provost Office and many others, student organizations, and many other partners that we have. I have said many times, so I will not go into the details. Yesterday, I mentioned briefly, how is everything here possible? they're like, you're a bunch of young people, and how could, all of this come together? So today, I also want to dive into, like our team that made all of this possible. And honestly, the whole Green AI won't happen without Professor Aisha Koskun. And the first meeting I was here last May, I was lucky to be invited by my professor at Harvard, who is a computer architect specialist, to join the meeting on the 11th floor. When I was in the meeting, the more I hear, the more I realize that as a computer architect, to build the next generation of chips, what can we do to solve this huge problem? It is a computer architecture problem, an operating computing system problem, data center operation problem, a PES, power and energy system problem. And that is the engineering side. And you have all the other social, economics, humanities, and politics. And that's when I started to wonder, how could we make the conversation more inclusive? And how could we bring actual changes, not just in those specific niches, which is great, but how could we convene people and discuss about the solutions? And that's why I was very lucky to be joined by my amazing teammates, including the people that are in the room right now. So if I call your team's name, please just stand up. And first of all, I'd love to say a big thank you for our speaker invitation and programming team. For all the speakers, you have seen hundreds of emails from us. It's all from them, actually. So Jay-Z, Tina, and other members. Yeah. And second, we have an amazing marketing team, that has helped us to make all the posters, all the videos, to make, people not from here, but from YouTube, from all across the world, from all the 6 languages or even more languages region to hear from us. So I also want to call out our marketing team to, stand up and say hi to us. Yeah. And thirdly, we have our amazing white paper team, that has made all of the white papers. I talked so many times, so I won't show the slides again, but our white paper team from Stella, from Caitlin, and Kiko, yeah. And fourthly, our amazing event support team that made all of the whole thing smooth, make sure the slides are right, our event support team, yeah. And internally, lastly, thank to our tech team. I cannot believe how everything could happen without you guys, but good job. Yes, and apart from our own internal members, I also want to deliver a big thank you for the supporters of Green AI. Aside from Professor Koskun, I'd love to deliver a special thanks to Karen Clopton, Paulo Carvalho, Suchi Gopa, and Professor Junwei Cao that has supported us from the last event, and the whole support has lasted till now. Thank you guys very much. And now the question is, what's next? We finished our beautiful lunch with a beautiful view, and for us, we'd love to stay engaged with many of you. Because when I was hearing all those panels, I believe it creates more questions than answers. Because for us, it's a hard job to put 50 speakers into like 15 hours. We have 7 people today in the panel 5, and only 50 minutes are there. So I believe that there's so many things that could be solved, and I just want to share another piece of personal observation. For the past 48 hours, we received many emails. First, before the summit, actually, I received an email. Does our conference have a Zoom link? Because they want to figure out their own digital, sustainable, carbon emission of the AI with the email address from @mcd.com. Does anybody here know where this company is? Like mcd.com. When I first received the email, I think this name is very familiar, but I don't know why. I don't remember the name. I go to Google, mcd.com is McDonald's. And that's just one example that what we have gathered so far. From our first summit till now, we have so many companies from like the digital publishing company, fashion company, food company that you might not even think of. Because for the past 2 days, we have people from tech companies, from the academia. It sounds relevant, but in fact, everything is relevant in this digital age. So that's why for us, we'd love to invite people who come here today, regardless of your background. We believe you can be a valuable addition to our team. We're going to carry out more research. We're going to help companies like those restaurant companies, those fashion companies, to figure out how we can solve their problem, how we can leverage our brilliant minds of the next generation to solve the issues of today. And those are not made up by us. It is actually happening. We receive those emails on a daily basis. And also yesterday, we have so many, and thanks to our participants from all the New England area, and from California, from Europe, many of them expressed interest. It is only once a year? My answer is no. We want to do this on a more regular basis. Here in Cambridge or Boston, Massachusetts, we have weekly meetings every Tuesday at 7 o'clock, in Leverett House. And we have, like monthly seminars where we hosted people and professors. And now we'd love to extend the invitation to all the people. And this could be in your school or even be in your organization. So, and recently, even banking companies are coming to us, asking us for a expert session to talk about this whole issue. So we think that this is not just going to happen today in this beautiful space. We'd also hope that you can carry the torch to your home organizations. And obviously, with the barcode, you can find more information. And I also mentioned previously for the industry partners, in the digital age, you have a beautiful reserve of your talents. But usually, your problems that you have are much more than the capacity you have. But what we do offer in the Great AI Institute are this pool of amazing talents that are, thirsty for questions, thirsty to make them into a solution. And as a volunteer, if you are busy with your work, we're hosting those events, we're doing those research. And if you want to join our marketing team, YouTube team, we have so many positions to really unite together. As I mentioned yesterday, the world are lack of smart people, and it also lacks the organization, an organized group of smart people. And we're there trying to bring people from different backgrounds to work together. So in the very end, I believe that you guys have learned your own journey in the past 48 hours. And I know many of you spent a lot of effort coming here from Europe, from Asia. And I just want to say a big thank you to all the attendees, all the speakers, all the sponsors, all the friends, all the partners, all the volunteers of the Great AI Summit. And with the, with the barcode there, it's a survey form. We'd love to hear your feedback. What do you like about us? What did you want us to improve? And we'd love to make this a two-way conversation. We'd love to stay in touch with you, and we'd love to hear from you and make our next event better. We believe and the last part is the difference between last summit and this summit. I believe many of the speakers have covered, but this year we have so much better space, so much better food, and so much more content, and so many more speakers. And we have identified just within the past 1 year how this topic has, has born from an academic problem to a discussion that is so prevalent in the society. So in the end, I just want to say that a big thank you for everybody who have come to the conference. And we have 30 minutes more as a networking session. Feel free to hang around. And if you want to talk to people from our team, we have the blue badges here with all of our teammates. And we'd love to stay in touch. And we'd love to unite to make the Green AI a reality for ourselves, for our community, and for the entire world. Thank you very much. Yeah, so eventually I'd love to welcome all the people, all the our organizers, our sponsors, our speakers, and all the attendees to join us on the stage for a group photo. Thank you very much. Yeah.